This new deadly nuclear submarine is ready to dominate the seas. Since the Second World War, the open sea has become more than just a travel route and more a battleground where countries with sophisticated and advanced technologies often showcase their military capabilities. The United States, a country with an impressive naval force, has taken over the sea with its new lethal nuclear submarine. What are the capabilities of this submarine? How did these vessels become an important determinant in a country's military? Join us as we explore the capabilities of the United States' new Deadliest 2025 nuclear submarine that is ready for action. Nuclear submarines have evolved through multiple generations, each bringing major innovations and improvements to underwater military technology. These advancements have transformed submarines from basic nuclear-powered vessels into highly sophisticated machines capable of long-term missions and remarkable stealth. The first nuclear submarines, developed in the 1950s, marked the start of this revolution. However, they were far from perfect. These early models were loud, which made them easier to detect, and their sonar systems, essential for navigation and detecting threats, were relatively rudimentary. While revolutionary for their time, these submarines were stepping stones toward more advanced designs. By the 1960s and 1970s, second-generation submarines emerged with streamlined hulls designed to enhance their speed and agility underwater. These new shapes not only improved performance, but also made the submarines less detectable. This period saw a shift toward designing vessels that were faster, quieter, and better suited to evade enemy detection systems. The 1980s introduced third-generation submarines, which brought a host of upgrades. These submarines were larger, enabling them to carry more weapons and supplies. They were also built to remain submerged for extended periods, thanks to improved autonomy and onboard systems. Crews benefited from better living conditions, making long missions more manageable. Additionally, many models during this era, such as the U.S. Ohio and Los Angeles classes, were equipped with reactors that could operate for over a decade without refueling. These innovations reduced the need for frequent maintenance, allowing the submarines to remain operational for up to 30 years without major overhauls. In the 1990s, fourth-generation submarines entered service, representing a new era of technological sophistication. These submarines were designed with advanced stealth features, including quieter propulsion systems like water jets and sound-dampening materials that made them nearly undetectable. The weaponry on fourth-generation submarines also saw dramatic improvements. For instance, American submarines could carry up to 50 cruise missiles, significantly boosting their firepower. These submarines became versatile platforms capable of both offensive and defensive missions, from launching nuclear strikes to engaging in conventional warfare. Nuclear submarines also serve different roles based on their classification. One of the most significant types is the ballistic missile submarine, which is designed to carry nuclear-armed missiles. These submarines act as a key component of a nation's deterrent strategy, ensuring that any attack would be met with a powerful response. Ohio-class submarines form the backbone of the U.S. Navy's strategic deterrence capabilities. Each submarine is equipped with 20 Trident 2D5 ballistic missiles, which are some of the most advanced and reliable in the world. These missiles can be armed with two types of warheads: the W-76, delivering a yield of 100 kilotons, and the W-88, offering a much higher yield of 475 kilotons, a single Trident. 2D5 missile can carry either 14 W-76 warheads or 8 W-88 warheads. With a range of 7,350 kilometers, these missiles can strike targets across vast distances, ensuring a robust second strike capability. The Ohio-class submarines are also highly maneuverable for their size, capable of reaching a submerged speed of 25 knots, which enhances their ability to evade detection and operate stealthily. In comparison, Russia's Borei-class submarines serve as the strategic counterpart to the Ohio-class. Each Borei-class submarine is armed with 16 Bulava missiles, each carrying up to 10 warheads, with yields ranging from 100 to 150 kilotons. These submarines are slightly faster than their U.S. counterparts, reaching a maximum submerged speed of 29 knots. This speed provides them with greater mobility, allowing them to operate effectively in diverse underwater environments while remaining elusive to potential adversaries. The second key category of nuclear submarines is the multipurpose class, or SSN. These submarines are versatile and capable of performing various missions, including intelligence gathering, anti-ship warfare, and land attack missions. One of the most advanced in this category is the U.S. Navy's Seawolf-class submarine. These vessels are designed for speed, stealth, and firepower, carrying up to 50 cruise missiles, including Tomahawks and Harpoons. The Seawolf is among the fastest submarines in operation, capable of achieving speeds of up to 35 knots underwater. However, their advanced technology comes at a high cost. Each Seawolf-class submarine costs approximately $4.3 billion, limiting the fleet to only 3 vessels. A more common and cost-effective alternative is the Virginia-class submarine. These submarines are designed for flexibility and affordability, making them the primary multi-purpose submarines in the U.S. Navy. Depending on the specific series, Virginia-class submarines can carry between 12 and 24 Tomahawk cruise missiles, giving them significant strike capabilities. They are slightly slower than the Seawolf class, with a top speed of 34 knots. But their widespread use reflects a balanced approach to cost and performance. Nuclear propulsion systems set these submarines apart from their diesel-electric counterparts. Nuclear-powered submarines can operate underwater for months without surfacing, allowing them to perform extended patrols and evade detection. The autonomy provided by nuclear reactors is unmatched, enabling submarines to cover vast areas and carry out diverse missions. The United States and the United Kingdom have completely phased out diesel-electric submarines, relying exclusively on nuclear propulsion for their fleets. This contrasts with most other nations, which still rely on diesel-electric models due to lower costs and specific operational needs. Only 5 nations operate nuclear-powered submarines: the United States, Russia, China, the United Kingdom, and France. These countries have invested heavily in nuclear technology to maintain strategic advantages at sea. For example, the Seawolf-class submarines are powered by S-6W nuclear reactors, which deliver a thermal output of 300,000 horsepower and shaft power of 57,000 horsepower. This enables the submarine to achieve high speeds and maintain energy-efficient operations. Nuclear submarines are technological marvels designed for stealth and strategic capabilities. One of their key advancements is the use of steam turbines that allow reactors to operate at most of their full power using natural circulation. This system eliminates the need for coolant pumps, drastically reducing noise. The quieter operation is essential for submarines to remain undetected during critical missions, making it a vital feature for modern naval warfare. The history of nuclear submarine accidents provides insight into the challenges of operating these advanced vessels. A total of 8 nuclear-powered submarines have sunk since the introduction of the technology. These include 4 Soviet, 2 Russian, and 2 American submarines. Each incident occurred under different circumstances, laying emphasis on the risks involved in their operations. The USS Thresher sank in 1963 due to hull damage, marking a significant loss for the U.S. Navy and prompting improvements in submarine safety protocols. In Russia, the most notable disaster was the sinking of the Kursk submarine in 2000 during a naval exercise. This tragic incident was caused by the explosion of an experimental torpedo on board, leading to catastrophic damage and the loss of the crew. A major difference between Russian and American nuclear submarines lies in their structural designs. American submarines are typically built with single-hull architecture, where the pressure hull doubles as the external hull. This design minimizes weight and enhances speed and maneuverability. In contrast, Russian submarines often utilize a double-hull design consisting of a strong inner pressure hull and an outer lightweight streamlined hull. Despite these differences, there is a growing trend towards single-hull designs in submarine construction. Advances in material science have played a crucial role in this shift. The U.S. Navy, for instance, uses high-strength HY-100 steel in its submarines, which allows the hull to withstand immense pressure at great depths. This material significantly enhances the survivability of single-hull submarines, narrowing the gap in durability between single-hull and double-hull designs. As technology progresses, even stronger materials are expected to emerge, further improving the structural integrity and overall capabilities of future submarines. The internal configuration of nuclear submarines is also worth noting. Submarines are divided into compartments with the number of sections depending on the vessel's design and purpose. Ohio-class submarines, for example, are divided into 4 main compartments. Among these, the second compartment is particularly significant. It houses 24 missile silos that run vertically through the entire height of the compartment, Each silo is sealed with a hydraulically operated lid, ensuring the protection and rapid deployment of missiles. This compartment is crucial for the submarine's role as a strategic deterrent, capable of delivering powerful nuclear strikes if required. In addition to structural advancements, propulsion and weapon systems in nuclear submarines continue to evolve. Noise reduction technologies such as natural circulation reactors and improved hull designs make modern submarines more difficult to detect. The combination of stealth, firepower, and survivability ensures that nuclear submarines remain critical assets for naval operations and national security. The missile launch system of the Ohio-class submarine is built for security and reliability under extreme conditions. The shaft lid is designed to seal tightly and endure pressures equal to the surrounding solid structure, ensuring no external damage or interference can occur. A locking mechanism is integrated to prevent unauthorized access. Inside the shaft is a starting cup, which is protected by a dome-shaped membrane made of phenolic resin reinforced with ASAS. This membrane acts as a barrier to keep water out when the lid is opened during pre-launch operations. Upon missile launch, explosive charges destroy the membrane, breaking it into central and side fragments to clear the shaft for the missile's exit. The Ohio-class submarine uses the advanced Mk-98 fire control system, enabling rapid readiness and launch of its missiles. The system can prepare all missiles for launch within 15 minutes. It calculates firing data, inputs the data into the missiles, performs pre-launch diagnostics, and confirms readiness. If necessary, the system can reassign targets for all missiles before launch. The launch process begins with a powder pressure accumulator, which generates gas by burning gunpowder. The gas passes through a water chamber where it is partially cooled and then enters the lower part of the launch cup. This process creates enough pressure to push the missile upward with an acceleration of approximately 10 Gs, ejecting it from the shaft at a speed of about 50 meters per second. As the missile ascends, the diaphragm at the top of the shaft ruptures, allowing the missile to pass through. Simultaneously, seawater starts to fill the shaft. To maintain the submarine's stability, the seawater is pumped into a dedicated replacement tank, ensuring the submarine remains at a consistent depth and position. Gyroscopic stabilizers and water ballast systems further manage the submarine's balance during launch operations. Missiles can be launched in rapid intervals of 15 to 20 seconds, even at depths of 30 meters, speeds of 5 knots, and in sea conditions with waves as high as 6 points. In cases of maximum operational demand, the entire missile load can be fired in a single coordinated salvo. Once the missile exits the shaft, its engine activates at an altitude of 10 to 30 meters above the water's surface, ensuring effective propulsion and trajectory. The Trident missiles carried by Ohio-class submarines are known for their precision and long range. These capabilities allow them to target and destroy heavily fortified locations, such as silo launchers and deeply buried command centers. Their extended range enables submarines to operate in the Atlantic and Pacific Oceans while remaining within U.S. naval protective zones, increasing their combat stability. This positioning allows the submarines to maintain constant readiness while staying well protected. Ohio-class submarines represent a critical component of the U.S. nuclear triad, with their effectiveness and low maintenance costs making them indispensable. They currently carry 2,116 of the 3,492 deployed nuclear warheads, accounting for 60% of the U.S. strategic arsenal. For multi-purpose nuclear submarines, launch silos have been replaced with universal systems equipped with drum magazines for deploying torpedoes, cruise missiles, and surface-to-surface missiles. The onboard nuclear reactors allow these submarines to operate for extended periods without resupply, enhancing their range and autonomy. This combination of advanced systems and enduring operational capabilities ensures Ohio-class submarines remain a vital asset in maintaining U.S. strategic deterrence. Modern nuclear submarines are engineering marvels capable of extended underwater missions. Theoretically, these vessels can undertake autonomous voyages lasting up to 6 months. However, in practice, the average mission duration for most submarines globally is closer to 2 to 3 months. This discrepancy is not due to technological limitations, such as running out of air, but for other, more practical reasons. Contrary to what many might assume, air supply is not a critical constraint for nuclear submarines. These vessels require a significant amount of air, not only to sustain the 150 to 160 crew members on board, but also for other operations such as surfacing, which involves blowing water tanks, and launching torpedoes from torpedo tubes. Despite these demands, air shortages are avoided through advanced onboard systems. Modern nuclear submarines use water electrolysis to generate oxygen. This process, which splits water molecules into hydrogen and oxygen, ensures a continuous supply of breathable air even during prolonged missions, effectively removing air supply as a limiting factor. The primary obstacle to extended submarine operations is human psychology. Spending long durations in confined, isolated spaces with the same small group of people presents significant mental and emotional challenges. Crew members must endure limited personal space, repetitive tasks, and a lack of fresh social interactions. The psychological strain caused by these factors becomes the main reason why missions are typically capped at 2 to 3 months. Efforts to mitigate these challenges include rotating crews and implementing strict routines. But the mental toll remains a significant limitation for prolonged underwater deployments. Looking ahead, the development of fifth-generation nuclear submarines is set to redefine underwater operations. These submarines will incorporate state-of-the-art technologies to enhance performance, safety, and combat capabilities. The United States has taken a leading position in this race, surpassing Russia in key areas of submarine innovation. For example, the American Seawolf-class submarines already feature advanced modular reactors. These reactors are housed in separate compartments and require no maintenance throughout the submarine's 40-year operational life. By contrast, Russia is still in the development phase of integrating such technologies. Another groundbreaking feature of the Seawolf class is the inclusion of autonomous rescue capsules. These capsules are designed to evacuate the entire crew in emergencies, significantly improving safety. Future submarines are also expected to retain duplicated reactor systems for added redundancy and reliability. Their propulsion systems will likely feature a water hammer mechanism controlled by a secondary electric motor during standard operations and by a reactor turbine during high-speed maneuvers. This dual system will enhance both efficiency and versatility. Automation will play a crucial role in these next-generation submarines. Fully automated control systems will centralize the crew in a single, highly protected module, reducing the need for personnel to move through various compartments. This will not only improve safety, but also address some of the psychological challenges of confined living spaces. In terms of weaponry, future submarines will be equipped with advanced armaments, including hypersonic missiles. These weapons, such as the Russian Poseidon II-M39, represent a significant leap in underwater combat capabilities. Hypersonic missiles are designed to travel at extraordinary speeds, making them nearly impossible to intercept. This Poseidon is an impressive underwater weapon designed for strategic nuclear deterrence. It is essentially a massive, autonomous torpedo powered by a nuclear propulsion system, enabling it to travel long distances underwater without requiring surface support. This weapon is equipped with a megaton-class nuclear warhead capable of catastrophic destruction. While specific details about Poseidon's technical specifications are scarce, estimates place its length between 16 and 24 meters, its diameter at 1.5 to 2 meters, and its weight at approximately 100 tons. The system can reportedly reach speeds of up to 70 knots and operate at depths of up to 1,000 meters, making it highly stealthy and difficult to intercept. Its primary purpose is to ensure devastating consequences for coastal regions, particularly those of adversaries. Its nuclear warhead is designed to create widespread destruction through explosive force and long-term radioactive contamination. This contamination would render affected areas uninhabitable for extended periods, crippling urban centers, infrastructure, and natural ecosystems. The weapon's strategic value lies in its ability to act as a powerful deterrent by guaranteeing unacceptable levels of damage in retaliation to aggression. Despite its technological advancements and destructive potential, the practicality of the Poseidon has been questioned by military experts. One major criticism is its operational speed. While capable of traveling long distances underwater, Poseidon's journey to its target could take several days. This makes it significantly slower compared to modern missile systems, which can deliver nuclear payloads within minutes. In high-stakes conflicts where rapid response is critical, the Poseidon's slow deployment time reduces its effectiveness as a reliable strategic weapon. Another issue is its overlap with existing nuclear arsenals. Modern intercontinental ballistic missiles and submarine-launched ballistic missiles are already capable of delivering precise and devastating nuclear strikes. These systems are faster, more accurate, and easier to deploy in various scenarios. Additionally, missile-based systems are less complex and more cost-effective compared to the development and maintenance of a nuclear-powered torpedo like Poseidon. The geopolitical implications of Poseidon's development also raise questions about its future. As tensions between Russia and Western nations persist, the weapon's existence serves as a symbol of strategic aggression. However, in a potential post-Putin Russia, there could be efforts to reduce reliance on such extreme weapons to improve international relations. Abandoning or scaling back Poseidon and similar projects might be seen as a step toward de-escalation and normalization of diplomatic ties. However, its practical application in modern warfare is limited due to its slow deployment and redundancy alongside faster, more accurate missile systems. While it remains a formidable deterrent, its long-term role in Russia's military strategy is uncertain, particularly as global political dynamics shift and new priorities emerge. Elon Musk's latest aerospace breakthrough just ended Russia's nuclear dominance, rewriting modern warfare. Reports have emerged of a nuclear-capable aircraft intercepting and neutralizing a Russian nuclear threat, an unprecedented military feat. Allegedly developed with input from Elon Musk, the aircraft is said to be powered by a nuclear reactor and advanced propulsion technology, challenging conventional aviation limits. But how does this anti-gravity fighter jet work? And could this signal the dawn of a new era in military supremacy? Join us as we uncover the shocking truth behind Elon Musk's alleged anti-gravity aircraft and its impact on global security. For over a century, war aviation has made strides at lightning speed. From the slow, fragile warbirds of the First World War to supersonic stealth warriors of the 21st century, technology has expanded the limits of speed, maneuverability, and firepower ever larger. With all of these rapid advancements, there is one fundamental principle that has not shifted. Traditional airplanes still operate under combustion propulsion and aerodynamics. Jet engines and stealth technology may have advanced considerably from the old days, but they are still bound by the same physical principles. There are now speculations that Elon Musk has taken advanced aerospace engineering to a new level altogether, designing a nuclear-powered anti-gravity aircraft. If the technology becomes a reality, the technology would render the traditional fighter jets obsolete, shattering the speed, fuel efficiency, and even radar detectability barrier. Since the advent of air-to-air fighting, the world's superpowers have been competing in a technology war that does not seem to end, each one wanting to control the sky. Dogfighting first made an appearance in World War I, where aerial fighter pilots used to clash, whereas World War II brought forth jet propulsion technology that revolutionized air warfare in general with the Messerschmitt Me 262 and P-51 Mustang airplanes. The Cold War introduced stealth fighters, intercontinental bombers, and nuclear-capable aircraft, driving the arms race to terrifying new heights. Drones and AI warfare have emerged as the hot topic of today's world, with the US MQ-9 Reaper and China's Winglong leading the pack. The future of war has remained in the balance for decades, with different top countries racing to overtake one another with superior technology. War in the air has evolved many times since the very first dogfightings during World War I, up to the most advanced drone wars in modern days. In the 1930s, the British Royal Air Force initially used radio-controlled de Havilland aircraft Tiger Moth target drones to train anti-aircraft weapons. This pioneering use of unmanned aerial vehicles laid the foundation for the modern drone warfare of today. The Germans further developed the idea in 1944 by designing the V-1 flying bomb, the first cruise missile, which was aimed at London during World War II. While not a direct description, it did unveil the concept of unmanned aerial threat. The US followed up with development of the idea using the AQM-34 Ryan Firebee unmanned vehicles to conduct reconnaissance in the Vietnam conflict, and then the MQ-1 Predator, which revolutionized air warfare with video monitoring in real time, GPS targeting, and precision strikes. But then emerged a new technology, a one that might make all the previous aerial war systems redundant. Elon Musk's game-changer, anti-gravity nuclear-powered fighter plane, might usher in a new era where speed, maneuverability, and endurance hitherto unheard of will be the norm of the day. Reports say Musk's airplane has no visible propulsion system, no heat signature, and no aerodynamic limits. It defies physics, going faster than possible, turning on a dime instantly, and vanishing from radar with no indication. The possibilities are staggering. United States-Russia tensions since the Second World War have grown through ever-enduring weapons races. The Cold War may have passed, but war over technological superiority has never really ended. Now, a new game-changer called gravity-defying plane is set to reverse the tables of power. The very idea of anti-gravity propulsion was once ridiculed as science fiction, but theoretical physics suggests that it could be possible. In contrast to conventional aircraft, which rely on airflow and thrust to create lift, an anti-gravity vehicle would create its own gravitational field, making such notions as air resistance and fuel efficiency moot. If the hypotheses regarding quantum field interaction and zero-point energy hold water, then this kind of airplane would be able to accelerate at almost instant speeds, possess unlimited maneuverability, and be completely invisible to radar. There would be no sound barrier, no heat signature, and no fossil fuel requirement, just naked, unadulterated flight. Conspiracy about secret U.S. military projects, black budget activities, and reverse-engineered extraterrestrial technology has plagued the subject for decades. But now news of leaked documents suggests Elon Musk unlocked the secret. Speculation mounted after a never officially confirmed event transpired. The future of air combat is going to be revolutionized. And leading this revolution is a name that has already revolutionized a few industries. Elon Musk. Known to have revolutionized the electric vehicle and space travel industries, Musk is now said to be revolutionizing military aviation with a nuclear-powered anti-gravity aircraft. If it materializes, not only will it upset conventional plane designs, but it will also render conventional fighter jets useless. Elon Musk has never been one to play it safe. With SpaceX, he revolutionized travel to space by accomplishing reusable rockets. His work at Tesla transformed the electric car and battery game. But could his next game changer come in the field of military aviation? Elon Musk has a history of making skeptics eat their words. When Tesla first announced its drive for electric cars, detractors laughed it off as a joke. Today, Tesla leads the EV market, driving battery technology and autonomous capabilities by leaps and bounds. Similarly, SpaceX's vision for reusable rockets was laughed off until it became a reality, reducing the cost of space travel by half. If Musk is getting into military aviation now, he will be doing it in the same revolutionary style. His innovations marry the newest technology with ambitiously advancing engineering targets. So a nuclear-powered anti-gravity plane is a logical way forward. While Musk has not publicly defined a nuclear-powered fighter aircraft plan, his present capabilities in next-generation materials, electric drive, and high-performance batteries position him well to undertake such a task. SpaceX's development of the Raptor engine, utilizing a full-flow stage combustion cycle, has already pushed rocket propulsion to new extremes. If Musk applies the same concepts to airplane propulsion, it could revolutionize aerial warfare. Also, Musk has indicated an interest in military applications. In one interview previously, he suggested that artificial intelligence would be the force to rule next-generation battles and potentially replace human pilots. With the U.S. military increasingly interested in autonomous fighter jets, Musk's involvement in such a venture is not impossible. Whispers of Musk's involvement in secret military projects began circulating after a reported event that never officially took place. Leaked memorandums show an unknown plane intercepted a Russian nuclear warhead mid-air at impossible speeds. Neither the Pentagon nor the Kremlin will confirm nor deny the incident. However, sources of intelligence claim that a never-before-seen aircraft with an unseen mode of propulsion was used. According to some sources, it wasn't any plane. It was Musk's. One of the most surprising claims about this plane is its power source. During the Cold War, the Soviet Union and the US both experimented with nuclear-powered aircraft, but the dangers were too great. Now, Musk is said to be bypassing these limitations with a miniature nuclear reactor, providing unlimited flight duration, similar to nuclear submarines that remain underwater for months. With anti-gravity propulsion and a limitless energy source, this aircraft would be able to fly indefinitely at hypersonic speeds, well beyond any present military capability. If such an airplane is available, it would revolutionize the world power equation. The US would have a better air superiority with such technology that traditional airplanes, bombers, and even missile defense systems would become redundant. More ominously, though, such a vehicle would entail with it the potential for an unbeatable first strike capability, a weapon that could travel anywhere on the globe in minutes with no warning whatsoever. Anti-gravity propulsion is the stuff of science fiction, but for decades it has been a legitimate area of scientific inquiry. Various theories and experiments indicate that gravity fields can be manipulated to make an aircraft hover, accelerate, and turn in ways that standard physics prohibits. One of the earliest concepts for anti-gravity propulsion was described by scientist Thomas Townsend Brown in the 1920s, who conducted experiments in electrogravitics, using high-voltage electrical currents to create lift. While mainstream science is skeptical, the concepts may have been researched in covert military initiatives. Another potential basis for anti-gravity propulsion is the work of Russian physicist Eugene Podkletnov, who in the 1990s claimed to have created a device lowering gravity through the use of superconductors. While his research was never widely replicated, it presented intriguing possibilities. Could it be done by Musk, taking these concepts and turning them into reality? If so, the world has never seen anything like an anti-gravity fighter aircraft. It would be impossible to detect by normal radar, could instantly accelerate, and could travel at staggering velocities without causing G-forces that would destroy a human pilot. To understand the significance of Musk's alleged breakthrough, we need to look first at how military air power has evolved. Early warplanes were slow, primitive biplanes with primitive machine guns. As the war went on, countries created faster, more maneuverable aircraft. By World War II, the German Messerschmitt Me 262 jet fighters and the American P-51 Mustang indicated the possibility of air superiority. The decades of the Cold War saw the development of sophisticated combat aircraft like the F-4 Phantom and the Soviet MiG family, leading to sophisticated stealth fighter aircraft like the F-22 Raptor and the Russian Su-57. These aircraft combined radar-evading technology and high-quality avionics, becoming nearly invisible to opposing air defense networks. Despite all the innovations, they all remained under the disadvantage of conventional jet power, which consumed massive amounts of fuel and put restraints on how far they could fly. Along comes anti-gravity propulsion, a theory technology that, if it exists, would totally change everything. Anti-gravity propulsion doesn't need air drag or combustion drives, but warps gravity itself for lift and drive. Scientists and military researchers have theorized how such a system might be built for decades, with speculation rampant as to secret government programs like America's alleged black budget projects. Exotic physics is believed to be the basis of anti-gravity technology, specifically theories involving quantum field interaction and zero-point energy. The forces, to some, would allow aircraft to fly at spectacular velocities, reverse direction in the blink of an eye, and fly without heat signatures that could be picked up by infrared detectors. Musk's incursion into the realm of high-end aerospace engineering is not surprising. Already with SpaceX, he has demonstrated reusable rocketry, returning first-stage boosters with precision, something once considered impossible. Tesla's work on battery technology has revolutionized electric propulsion. If anyone has the intelligence, resources, and motivation to push the boundaries of flight, it is Elon Musk. There were rumors of Musk's secret military activities first surfaced after sources reported that one of the test aircraft had destroyed a Russian nuclear strike. The incident remains highly classified, with the Pentagon and Kremlin both labeling the incidents as not being true. However, leaked memos reveal that the alleged aircraft, speculated to have been produced by Musk's independent space research unit, employed a groundbreaking new propulsion system which allowed the plane to intercept the nuclear warhead in flight. If Musk's plane had existed, then one of the most revolutionary things about it would have been its power source. Nuclear-powered planes have been in theory since the Cold War era, when the US and the Soviet Union tested nuclear-powered propulsion for intercontinental bombers. Safety issues and technological shortcomings cut these experiments short. In Musk's case, the plane is said to employ a small nuclear reactor to generate huge amounts of energy without the need for traditional fuel. This would allow it to remain airborne indefinitely, just as nuclear submarines remain underwater for months without needing to be refueled. Combine this with anti-gravity propulsion, and this plane could, in theory, fly at hypersonic speeds, far greater than anything seen in military flight. If such an aeroplane were to enter the military aviation market, the international military balance of power would shift dramatically. America would possess unparalleled dominance over others, and classical fighter jets, bombers, and even missile defense platforms would become unnecessary. Countries like China and Russia have spent billions of American dollars creating advanced fighter aircraft and hypersonic missiles, which would be at a tactical disadvantage. In addition, an anti-gravity plane would potentially change air dominance. Dogfighting, in the way to which we have become accustomed, would be a thing of the past if one aircraft could travel instantly at record speed and remain invisible to standard radar. It would then raise serious questions among military planners regarding the feasibility of an unbeatable first strike capability. Although the claims are sensational, the majority of experts rule them out. There has been no material evidence presented to substantiate Musk's anti-gravity aircraft. Some say such technology exists in the theoretical phases of physics and is unlikely to be accomplished in the near future. Moreover, there are significant legal and ethical consequences to using nuclear-powered flight. Global treaties strictly regulate the application of nuclear technology and weapons, and the implementation of this system can lead to another arms race. The idea of nuclear-powered aircraft is not new. Both the United States and the Soviet Union studied nuclear propulsion for military aircraft during the Cold War. The U.S. Air Force's Nuclear Energy for the Propulsion of Aircraft program sought to develop bombers with unlimited endurance. The Soviet Union also experimented with nuclear-powered aircraft, including the Tupolev Tu-119. All of these projects were shelved, however, due to radiation exposure hazards, safety concerns, and the advent of mid-air refueling, which made nuclear-powered bombers redundant. Musk's fighter plane would need breakthroughs in reactor miniaturization, radiation shielding, and heat extraction if it is driven by a nuclear reactor. If Elon Musk had built a functioning nuclear-powered anti-gravity airplane, it would have been the biggest shift in military power since the invention of the nuclear bomb. It would be invincible, able to outmaneuver any existing fighter, evade missile strikes, and remain airborne indefinitely. The stakes for international security would be huge. America, already the world's preeminent military power, would be a virtual force to be reckoned with. Russia and China would have to respond, perhaps further enhancing their own secret space activities. Would it start another arms race? Nations around the world would be vying to invent their own anti-gravity aircraft, the way they have competitively sought out developing their own nuclear bombs and stealth fighter. The dynamics would be suddenly greatly changed with conventional air power obsolete in a blink of an eye. Skeptics might criticize that the airplane is strictly fictional. Anti-gravity technology still needs to be demonstrated, and nuclear-powered jets have monumental engineering challenges. However, clandestine U.S. military programs have long been thought to be engaged in revolutionary aeronautic technologies. The mythical TR-3B, rumored for many years to be a black program, is reported as an anti-gravity plane, which is already in use. Beyond the application for military purposes, this technology can transform commercial air travel. Commercial flight on anti-gravity, a commercial jet, could put long-distance flight out of commission and crossing continents virtually overnight. Companies like Lockheed Martin, Northrop Grumman, and Boeing would be forced to radically refashion their business models. The classic jet maker's model might be discredited by the focus now put on anti-gravity propulsion. The space business would also be revolutionized. Satellite launches and deep space flights would be so much cheaper and within reach with anti-gravity technology. offering new frontiers in space travel. If Musk's anti-gravity aircraft is true, the global military balance would change overnight. The United States would enjoy total air superiority, rendering conventional fighter planes, bombers, and even missile defense systems obsolete. China and Russia, the two largest investors in hypersonic missile technology, would have their strategic advantage drastically undermined. This could precipitate another arms race as nations scramble to develop their own versions of the technology. Governments might also compel global treaties against its application in a bid to prevent one nation from controlling airspace. No matter if Musk's so-called plane actually exists or not, the truth is, the future of air warfare is evolving at warp speed. With artificial intelligence, autonomous drones, and hypersonic missiles still on the drawing board, conventional fighter jets are a potential relic of the past in a heartbeat. If anti-gravity technology is achievable, then it would be a new book in the history of man, a new book where the skies shall no longer be restrained by the laws of physics as they have been known so far. But the question is mankind ready to take such a giant leap? AI is already transforming military aviation from unmanned drones to AI-guided systems. Musk, an investor in AI technologies through Tesla and Neuralink, has time and again warned of the dangers of AI, while also pushing its boundaries at the same time. An anti-gravity aircraft would most likely integrate AI to read the movement of enemy forces, switch direction while flying, and engage combat on its own. It would make dogfighting useless since AI could outmaneuver any human pilot in speed. In addition to quantum computing, the aircraft could come to strategic decisions real-time, and thus it would be tactically unbeatable. Elon Musk's supposed anti-gravity plane is either the greatest military innovation in history or the biggest secret of all time. Anti-gravity propulsion is still purely theoretical, and nuclear-powered aircraft are confronted with huge engineering hurdles. Given Musk's history of doing the impossible, it might be too early to write this off as a wild claim. If there is an anti-gravity nuclear-powered fighter plane, it will change military strategy, aviation, and world power dynamics forever. Something is certain. If Musk is anything to do with it, the future of war will be different forever. Nations in the global power struggle are waking up to a brutal truth. Real dominance isn't measured by just the latest aircraft, but by the ability to stay one step ahead of any threat. With tensions soaring, especially as China, Russia, and the United States sharpen their military edges, innovation becomes the deciding factor. The SR-72 Dark Star, unveiled at the Aerospace Air Show, stands as a beacon of future warfare capabilities. How does this stealthy new spy plane tilt the scales of power in the world? And more crucially, how will it impact China's relentless military ascent? The stakes have never been higher. Join us as we dive into the Dark Star's potential to reshape aerial reconnaissance and alter global defense strategies. At the Aerospace Air Show, the SR-72 Dark Star emerged as the main attraction. This new pilotless craft combines remarkable speed with advanced technology and promises to transform defense strategies worldwide. Remote-controlled flying machines, known as drones or aerial systems, operate without human occupants. Military forces developed them in the 1900s for missions too monotonous, hazardous, or contaminated for human aviators. By the 2000s, these robotic flyers had become essential tactical assets. The Dark Star represents the latest evolution in this technology. The aircraft's debut has alarmed Chinese defense specialists, who now face the challenge of countering a surveillance platform that can penetrate their most protected airspace. As aerial reconnaissance systems continue to advance, the balance of global surveillance capabilities shifts accordingly. The Lockheed Martin SR-72, often called Son of Blackbird or Dark Star, is an American hypersonic concept for intelligence, surveillance, and reconnaissance that Lockheed Martin privately proposed in 2013 as a successor to the retired Lockheed SR-71 Blackbird. In 2018, company executives said an SR-72 test vehicle could fly by 2025 and start service in the 2030s. When the United States Air Force lost a remarkable intelligence-gathering platform, this led to an interesting shift in military aviation thinking. While the industry initially focused on developing stealthy aircraft that could evade radar detection, a compelling counterargument emerged. As adversaries developed increasingly sophisticated ways to detect stealth aircraft, some experts proposed a bold alternative. Pure speed might be more effective than stealth for penetrating defended airspace. This perspective challenged conventional wisdom and sparked a fresh debate about the future of reconnaissance aircraft. Early rumors about the SR-72 started popping up around 2007. People were saying Lockheed Martin had something big in the works, an airplane that could fly 6 times faster than sound. To put that in perspective, while the old SR-71 was incredibly fast, this new plane would double that speed, hitting around 4,000 miles per hour. At first, these were just rumors, but Lockheed Martin teamed up with Aerojet Rocketdyne back in 2006 to create the engine for this next-generation aircraft. When a project for another aircraft was canceled in 2008, they took the special jet engine technology from it and used it for the SR-72. They wanted an engine that could work at all speeds, from sitting still to flying faster than anyone had gone before. For the new SR-72, engineers created an ingenious hybrid propulsion system. The aircraft uses 2 engines working together through a single inlet and exhaust. At takeoff and lower speeds, it relies on conventional jet engines to build momentum. Once the aircraft reaches high velocities, it switches to scramjet technology, which thrives in supersonic environments. This dual-system approach solves the long-standing challenge of efficient acceleration across all speed ranges, from standstill on the runway to hypersonic flight at more than 5 times the speed of sound. The seamless transition between propulsion methods represents a breakthrough in aerospace engineering that could revolutionize both military and civilian aviation. When a plane flies 5 times faster than sound, it gets so hot it could melt normal metal frames. To solve this problem, engineers looked at using special materials that mix carbon, ceramic, and metals. These are not new materials. They have been used before in long-range missiles, and the space shuttle is now retired. These materials can handle extreme heat without melting or breaking apart. On the 1st of November 2013, a piece about Lockheed Martin Skunk Works' SR-72 project appeared in Aviation Week in Space Technology. The news drew so much interest that Aviation Week servers could not handle the traffic. The company revealed plans to build a demonstration aircraft that could be flown with or without a pilot. This test aircraft would be 60 feet long, roughly the size of a Lockheed Martin F-22 Raptor, powered by 1 full-scale engine, and would fly for several minutes at Mach 6. They aimed to have it ready by 2018 for flight testing, which would follow the schedule for the hypersonic high-speed strike weapon. General Mark Welsh, who led the Air Force, spoke on November 13, 2013, about his interest in planes that fly extremely fast. He explained that these speedy aircraft would give enemies less time to react when the Air Force takes action. Welsh believed hypersonic technology would create a significant advantage in future conflicts. The general noted that such high-speed capabilities would allow forces to strike quickly and decisively, potentially changing how military operations are planned and executed. By late 2013, the Air Force rejected funding for the SR-72 project. Money was tight, so they chose Northrop Grumman's RQ-180 stealth drone instead. This alternative was more affordable and simpler to manufacture. The military selected this particular drone for its ability to gather critical intelligence in hostile territories where enemy defenses pose significant threats. The RQ-180 was designed specifically to operate in contested airspace, collecting valuable data while maintaining a low observable profile to avoid detection. In December 2014, the National Aeronautics and Space Administration hired Lockheed Martin to see if they could build the SR-72's engine using today's jet technology. They paid about $892,000 for this study. In May 2015, people reported that SR-72 would gather intelligence and attack targets, but nobody said what weapons it would carry. This makes sense because current weapons probably would not work well on a plane flying 6 times the speed of sound up to 80,000 feet high that needs hundreds of miles to turn around. They'd likely need to create brand new sensors and weapons just for these extreme speeds. In March 2016, Lockheed Martin's CEO Houthi claimed they were close to a breakthrough that would let their SR-72 reach 6 times the speed of sound. She said they could build a test aircraft the size of an F-22 fighter for less than $1 billion. Back in the year 2017, Lockheed Martin made a bold announcement. The legendary SR-72 was finally coming. This hypersonic aircraft would hit speeds above Mach 6. That's over 4,500 miles per hour, and be ready in the early 2020s. In a moment of surprising candor, Vice President Rob Weiss acknowledged what many already knew. The company had been dangling the hypersonic carrot for 2 decades with little to show for it. It's always been just around the corner, he admitted. But this time was different, Weiss insisted. The technology had matured, and with DARPA's partnership, they were finally ready to put this breakthrough speed machine in military hands. In 2018, another Lockheed executive, Jack O'Banion, credited new manufacturing techniques for the breakthrough. He claimed 3D printing and better computer models made the plane possible, saying they could not have built it just 5 years earlier. The new technology allowed the team to build cooling systems directly into the engines, which was a crucial advancement. In February, Lockheed Martin's story took a dramatic turn when Aeronautics Vice President Orlando Carvalho finally admitted that despite years of ambitious promises and flashy announcements, not a single SR-72 aircraft had been constructed or tested. The uncomfortable reality behind their hypersonic program became clear as Carvalho revealed that their research was primarily being channeled into weapons development rather than the revolutionary aircraft they had been promoting so enthusiastically to the public and military stakeholders. Throughout his carefully worded statements, observers noticed Carvalho deliberately shifting terminology away from specific references to the SR-72 in favor of the much more ambiguous phrase, reusable vehicle, a linguistic sleight of hand that gave the company significantly more flexibility as their technological aspirations evolved. This unexpected confession from such a high-ranking executive effectively demolished any remaining credibility in their previous bold claims about delivering a functional Mach 6 aircraft by the early 2020s, leaving many aerospace experts and military planners questioning whether the promised breakthrough in hypersonic flight would ever materialize. Later that year, on November 2018, Lockheed Martin announced plans for an SR-72 prototype to fly by 2025. They also mentioned the aircraft would carry hypersonic missiles. If all goes according to plan, the SR-72 might enter service sometime in the 2030s. Before the SR-72, there was the SR-71 Blackbird, the fastest aircraft ever built. This incredible spy plane could fly at over 3 times the speed of sound, leaving everything else in its dust. Born in Lockheed's secretive skunk works during the 1960s, the Blackbird was not just fast, it was untouchable. The genius behind it was engineer Kelly Johnson, who took the earlier A-12 design and made it longer to carry more fuel and accommodate 2 crew members instead of 1. When the Air Force unveiled the sleek black beast in July 1964, jaws dropped. It looked like it came straight from the future. By 1966, it was already zooming over hostile territory, gathering intelligence from heights and speeds that made it impossible to catch. Locals in Okinawa, Japan nicknamed it the Habu after a dangerous snake fitting for an aircraft that slithered through the sky faster than any missile could reach it. It flew at Mach 3.2 in 85,000 feet during missions, which let it escape or outrun threats. If radar picked up a missile launch, pilots would simply speed up to get away. The plane carried special equipment for spying missions, signal detectors, radar, and a camera. These aircraft needed so much preparation that each one typically flew just once a week. Out of the 32 planes built, 12 crashed due to accidents, but none were ever shot down by enemies. In 1974, the SR-71 broke the record for the fastest flight between London and New York. By 1976, it became the fastest air-breathing crewed aircraft, taking the title from its predecessor, the Lockheed YF-12. The Blackbird still holds all 3 world records today. The Air Force retired the SR-71 in 1989, mostly for political reasons. A few planes were briefly brought back before being retired again in 1998. NASA was the last to use the Blackbird for research until finally retiring it in 1999. Since then, spy satellites and drones have taken over its role. The dark star concept brings to mind the long-rumored Aurora project. Aviation enthusiasts and defense watchers have speculated since the 1980s about Aurora as a secret hypersonic replacement for the SR-71 Blackbird. Though the Pentagon never officially confirmed Aurora's existence, unusual atmospheric phenomena and sonic booms reported in the 1990s fueled theories about classified hypersonic test flights. Some analysts now wonder if the SR-72 represents the public evolution of technologies potentially developed under the Aurora program, or if lessons learned from earlier classified hypersonic research inform the current design. Aurora is supposedly a secret American spy plane from the mid-1980s, but there is no real proof it ever existed or flew, and many consider it just a myth. The United States government has always denied building such an aircraft. Aviation experts looked into it and concluded that claims about Aurora are based on guesswork or indirect evidence, so there is little reason to doubt what the government says. Ben Rich, who once ran Lockheed's secret Skunk Works division, explained in his 1994 book that Aurora was just a code name, a Pentagon colonel randomly assigned to funding for the B-2 bomber competition. Somehow this name leaked to the media. However, in 2006, aviation expert Bill Sweetman, who has tracked secret projects for years, said after researching it for years, he believes Aurora is probably being developed, helped by recent technology advances that have finally caught up with the original vision from decades ago. The Aurora mystery began with a simple slip-up in 1985. Sharp-eyed reporters at the Los Angeles Times and Aviation Week caught something they were not supposed to see: the word Aurora mysteriously appearing in the public United States budget. This was not just any line item. The documents showed a massive $455 million earmarked for some kind of secret aircraft production coming in 1987. The government had not meant to reveal this black project. This accidental disclosure sparked decades of speculation about what might be hiding in America's classified hangars: a hypersonic spy plane that could leave the SR-71 Blackbird in its dust. Aviation Week said Project Aurora was not just one plane, but a collection of unusual aircraft. They claimed funding grew to $2.3 billion in fiscal 1987, based on a procurement document they obtained. Later in his 1994 book, Ben Rich, who used to run Lockheed's secret Skunk Works division, explained that Aurora was simply the budget code name for the competition that eventually produced the B-2 Spirit stealth bomber. By the mid-1990s, people reported seeing strange aircraft over California and the United Kingdom. These reports included unusual contrail shapes, sonic booms, and other phenomena that suggested the United States had built such an aircraft. While none of these sightings were ever officially connected to any specific program or aircraft, people often used the name Aurora to describe whatever they thought they were seeing. Starting in mid to late 1991, a pattern of unusual supersonic compression waves echoed across Southern California. These were not random events. They were captured by United States Geological Survey sensors designed to track earthquakes. What made these booms interesting? They didn't match the acoustic signature of the massive space shuttle. They seemed to come from something smaller. Adding to the mystery, records showed neither the space shuttle nor NASA SR-71B aircraft were flying on the days these booms occurred. This led aviation experts to a startling theory: the Black Star. Military watchers believed this would give the United States the ability to deploy satellites or conduct reconnaissance missions with almost no warning. The strange sonic booms, unusual funding gaps, and glimpses of triangular craft all seem to point to Black Star's existence, though the Pentagon has never confirmed it. In March 2006, Aviation Week and Space Technology magazine reported that the United States had been operating a secret spaceplane program called Black Star since the early 1990s, a revelation that shocked the aerospace community. According to the report, after the Challenger disaster in 1986, U.S. intelligence agencies needed a backup plan for putting spy satellites into orbit, and Black Star was supposedly their answer. providing a flexible alternative to conventional rocket launches. The revelation became even more intriguing when sources suggested the Air Force's own Space Command knew nothing about the program, indicating Black Star wasn't a military operation, but rather a system managed by an intelligence agency like the National Reconnaissance Office. The Black Star system reportedly used two specialized vehicles, a larger carrier aircraft that would take off from a conventional runway, carrying a smaller spaceplane, and once at high altitude, the spaceplane would separate and rocket into orbit, complete its classified mission, and then glide back to Earth without detection. Despite numerous sightings by credible witnesses and detailed reporting from a respected aviation publication, the government has never confirmed Black Star's existence, allowing it to remain one of the most persistent and fascinating mysteries in modern aerospace history. Aviation Week described Black Star as a clever two-stage system for reaching orbit, not just a single spacecraft. The first component was the SR-3, a large delta-winged aircraft similar to the B-70 Valkyrie bomber. This massive aerodynamic mothership was designed for exceptional speed, building on concepts Boeing had patented in the 1980s. Beneath the SR-3 sat the real game changer, the XOV, also known as the Experimental Orbital Vehicle. This compact spaceplane was nestled between two engine clusters, with each cluster housing 2 or 3 powerful engines. This clever arrangement created an integrated system where the smaller craft could leverage the larger vehicle's capabilities. The concept was elegant in its simplicity. The SR-3 would ascend to approximately 100,000 feet before releasing the XOV. Once free, this compact vehicle, resembling the earlier X-20 Dinosaur project, would ignite its rockets and accelerate into orbit. This approach, if implemented, would have addressed numerous challenges associated with conventional space launches, providing the flexibility and reusability that SpaceX would later pioneer decades after Black Star's rumored development. Once released from its mothership, the XOV would fire up its rocket motors, likely aerospike engines similar to those on the Lockheed Martin X-33. This little space plane could do both suborbital hops and full orbital missions. One Aviation Week source claimed it could reach an orbit 300 miles above Earth, depending on what it was carrying and the mission plan. After completing its mission, the XOV would glide back through the atmosphere and land on a normal runway, just like a plane. The whole system, a jet-powered mothership carrying a rocket-powered spaceplane, was not entirely new. It shared some similarities with the civilian Tier 1 system and NASA's X-15 aircraft. But Black Star could go much faster, enough to reach orbit. If real, this capability would have given the United States military or intelligence agencies a way to put satellites in orbit or conduct space missions without anyone knowing, which was a perfect tool for the post-Cold War era. The YF-23 was a failure. Many believe this revolutionary stealth fighter was lost to history after losing the U.S. Air Force contract to the F-22 Raptor. But now, decades later, Japan is bringing it back, with cutting-edge upgrades that could shift the balance of power in the skies. As tensions intensify in the Indo-Pacific, Japan is depending on the mind-blowing capabilities of the revived new YF-23 to deter the intensifying Russian and Chinese threats. But how does this restored combatant compare with contemporary opponents? And why is its comeback creating shockwaves within the international defense community? Join us as we unlock the secrets of Japan's $500 million YF-23 supersonic plane. Few aircraft in the world of military aviation have possessed as much charisma for airplane enthusiasts as the YF-23 Black Widow II. A marvel of stealth design, speed, and high-altitude aerodynamics, it was the pinnacle of American air superiority for a while. Yet due to its groundbreaking innovations, the YF-23 lost out to the YF-22 in the early 1990s, and its place in history remains only as an engineering masterpiece that never quite lived up to what it could have been. The YF-23 had for years been a relic, and almost was of history. But in a dramatic reversal, Japan resurrected this mythical plane, this time equipped with the latest cutting-edge technologies capable of reshaping the very face of air warfare. The new F-23J has next-generation stealth technology, autonomous battle systems fueled by artificial intelligence, and hypersonic speed, placing Japan in the world's arms radar. It was in the late 80s that the U.S. Air Force started creating a new air superiority fighter to replace the outdated F-15 Eagle and maintain American air supremacy. This led to the Advanced Tactical Fighter Program, which was a high-profile contest between two of the most powerful aerospace giants, Lockheed Martin and Northrop Grumman. This was the contest to select the next-generation air dominance fighter. Lockheed Martin unveiled the YF-22 and Northrop Grumman unveiled the YF-23, an aeroplane most aeronautics professionals believed mastered in its era. Northrop Grumman also worked with McDonnell Douglas in creating the YF-23, a fighter plane that most see as futuristic. In its design, compared to other ordinary fighter planes, the YF-23 possessed a slender, diamond-shaped airframe, greatly suppressing its radar cross-section and allowing it to approach invisibility before enemy radar screens. The airplane's V-shaped tail made all vertical stabilizers unnecessary, hence increasing its ability to hide itself. But what actually set the YF-23 apart was its super cruise capability and speed. Equipped with two General Electric YF-phone 120 or Pratt & Whitney YF-phone 119 engines, the aircraft could cruise supersonically without the use of afterburners. The ability gave the aircraft a big advantage over existing fighters, since afterburners have a tendency to greatly increase infrared visibility, making aircraft more vulnerable to enemy tracking. The YF-23 Black Widow II was an engineering masterpiece with a revolutionary, stealthy, high-speed, and aerodynamic design. Its V-tail and diamond-shaped fuselage radically reduced its radar cross-section, and it was among the stealthiest fighter jets ever built. Though the YF-23's greatest asset was its ability to strike unseen from long distances, it also featured super cruise, where it could sustain supersonic flight without afterburners. Even though these were its advantages, the U.S. Air Force ultimately chose the YF-22, which went on to become the F-22 Raptor. The basis for making this choice included a number of factors. The YF-22 had superior dogfighting performance that the Air Force believed would play a significant role in future air combat. Lockheed Martin also proposed mass production of its plane at reduced costs and less complicated procedures. Therefore, the YF-23, faster, stealthier, and more advanced, was relegated to the back burner forever. For generations, the YF-23 became a historical footnote, but with shifting world politics and advances in technology, Japan revived this once-abandoned marvel, this time with cutting-edge updates that could potentially change air dominance. Japan's decision to reactivate the YF-23 is not an accident. The Indo-Pacific area has become a geopolitical tinderbox, with the tensions between the world powers heightened. Japan had been relying on U.S. military protection for decades under their security agreement umbrella. However, China and Russia's recent advancements in the military have prompted Japan to rethink its traditional dependence on foreign allies. The constant missile tests of North Korea and the assertive territorial claims of China in the East China Sea have left Japan vulnerable to potential aerial attacks. China's Chengdu J-20 and Russia's Su-57 in particular have left Japan's defense establishment worried, introducing a treacherous angle to air superiority in the region. In recognizing the urgency of the situation, Japan has begun down a very aggressive road towards establishing its own state-of-the-art fighter plane program. Reactivation of the YF-23 is a cautious strategic move to bypass a decades-long development program through the development of an existing airframe that has already been proven. Instead of developing an all-new airframe from scratch, Japan is building its sixth-generation fighter, dubbed the F-23J now, from the breakthrough design of the YF-23. It allows Japan to accelerate its technological advancements and narrow the capability gap between China, Russia, and Japan's current technologies. For decades, it seemed as if the YF-23 was only going to amount to something out of historical memory. Not anymore. With Japan under pressure from escalating international tensions and taking note of an opportunity to bring this lost work back to life. The F-23J is more than just a revival of the YF-23. Japan has completely overhauled the aircraft, and it is now one of the world's most technologically advanced fighters. The foundation of the F-23J is an advanced stealth system that is ahead of anything ever made before. The YF-23's original radar-absorbing materials are upgraded with plasma-based stealth technology, a system that deforms electromagnetic waves to drastically reduce the aircraft's radar signature. In addition, the aircraft's composite materials and electromagnetic wave absorbers make it practically invisible to radar and infrared detection systems. The most impressive feature of the F-23J is probably its power plant. Japan's IHI Corporation has developed a next-generation XF91 low-bypass turbofan engine, which can produce up to 44,000 pounds of thrust. This allows the F-23J to achieve supercruise speeds, sustain supersonic flight without afterburners, while greatly reducing its infrared signature. During flight tests, the engine has demonstrated moments of hypersonic speed above Mach 5, so the F-23J is one of the fastest fighter planes ever created. To supplement its unadulterated speed, Japan has endowed the F-23J flight systems with artificial intelligence. Onboard computer programs also support the pilot in threat analysis, automatically identifying enemy planes and projecting flight paths in real time. Autonomous dogfighting is also available in the F-23J, with AI dynamically recalculating flight vectors in a matter of microseconds after the identification of threats. The cockpit also contains voice control, enabling pilots to operate primary functions without needing to use their hands, a function that can be highly beneficial in high-intensity combat situations. Yet another groundbreaking feature of the F-23J is its loyal wingman integration of unmanned aerial vehicles or drones. The fighter will fly alongside formations of autonomous drones that can be used as missile launch platforms, recce vehicles, or electronic warfare assets. The drones are instrumented as force multipliers to augment the combat capability of the fighter with minimal risk to human lives. The F-23J's mid-air drone control capability is a quantum leap in autonomous warfare. Japan's decision to bring the YF-23 back to life isn't sentimental. It's a matter of survival. Japan has relied for decades on the US, Japan's security alliance, for its security. China's abrupt militarization, Russia's and North Korea's, compelled Japan to rethink its reliance on US defense. China's J-20 Mighty Dragon, Russia's Su-57 Felon, and North Korea's missile technology have put Japan at risk of potential aerial assault. Japan's current F-15J fleet, while potent, is rapidly aging. Even the F-35 Lightning II, which Japan has purchased from the US, is basically a multi-role fighter, not a specialized air superiority plane. Recognizing the urgent need for a homegrown next-generation fighter, Japan began the FX program, a multi-billion-dollar program to develop a sixth-generation aircraft by the 2030s. Rather than start over, Japan perceived value in the YF-23's pioneering design. Through the use of a proven vehicle as a basis, Japan would be able to speed up development, be economical, and install next-generation tech into a years-ahead-of-time aircraft already. The ultimate product? The F-23J, a sixth-generation fighter that will dominate the skies of tomorrow. The new technologies added to the F-20J make it the jack-of-all-trades fighter of modern air-to-air combat. Its most advanced feature may be in stealth, which has been taken to unprecedented levels. While the original YF-23 was difficult to locate in the first place, the F-23J employs plasma-based stealth technology that warps electromagnetic waves to absorb and deflect radar waves. This innovation renders it almost invisible, even to the most sophisticated radar systems. In addition to this, Japan's quantum radar, along with Mitsubishi Electric, allows the F-23J to detect the stealth fighter jets, such as the J-20 and Su-57, eradicating their greatest advantage and leaving Japan in the premier position of air superiority. Aside from stealth capability, the propulsion system of the F-23J makes it stand out from its predecessors and competitors. Japan's IHI Corporation has developed the advanced XF91 turbofan engine, which allows the aircraft to cruise at supercruise velocities above Mach 2.5, far beyond the capability of any F-22 Raptor. Record-breaking bursts of hypersonic speed above Mach 5 have been achieved in flight tests, and the F-23J may be the fastest fighter plane ever conceived. The combination of speed and stealth ensures the F-23J can enter and leave combat at will, enjoying a tactical upper hand in any fight. The incorporation of artificial intelligence places the battle performance of the F-23J on an even greater level. With its flight system managed by AI, the jet is able to dogfight automatically, using real-time analyzed data to predict adversary movement and alter flight paths accordingly. This not only enhances pilot performance, but also reduces response time on high-threat missions. The AI-powered system is designed to assess danger in the blink of an eye, launch countermeasures independently without the intervention of a human entity, and even engage coalition forces in real-time conversation, making the F-23J a smart and reactive warfighter. The second innovation of the F-23J is the integration of its Loyal Wingman drone feature, which allows the fighter to command an armada of drones AI-capable. The drones serve as carriers of missiles for faraway combat, reconnaissance vessels for instantaneous battlefield intel gathering, and electronic warfare specialists with jamming capabilities on the enemy's radar. By engaging these unmanned aircraft, the F-23J is a more effective instrument of war and reduces the risk to human pilots. The system turns the aircraft into something greater than a fighter aircraft. It is a force multiplier with the ability to control the air battle like never before, with unprecedented accuracy, acumen, and firepower. The fighter jet capabilities put it on par with the world's leading fighter planes. Compared to America's F-22 Raptor, the F-23J outshines its ancestor in stealth capabilities as well as in speed. Whereas the F-22 enjoys a high agility and close air combat capability, the F-23J, with its emphasis on long-distance combat and associated drone system, is far more versatile. Where the F-35 Lightning II is essentially an air-to-ground, multi-role combat aircraft, the F-23J is specifically an air supremacy fighter designed to dominate the airspace. To counter China's J-20 Mighty Dragon, the F-23J is the big threat. The J-20's strongest suit is its long-range strike capability, but the F-23J's quantum radar system, a next-generation system capable of detecting stealth fighters, renders the J-20's stealth capability irrelevant. The F-23J also leaves Russia's Su-57 Felon in its rear-view mirror with respect to speed and electronic warfare capabilities. Coupled with hypersonic propulsion and AI-powered combat systems, the F-23J could even potentially take out enemy fighters before they even knew it was coming. The F-23J has made waves within the global defense community. For decades, China has regarded itself as the dominant air power in the Indo-Pacific and has been concerned about increasing military power of Japan. Stealth capabilities and extended range of the F-23J pose an immediate threat to China's J-20s and may negate Beijing's regional strategic advantage. Russia has also noticed, with military analysts speculating that the F-23J might outclass the Su-57 and push Moscow to fast-track development of its own sixth-generation fighter. Even Japan's closest allies reacted in ambivalence. The United States, while it backs Japan's military modernization, is wary of the F-23J's potential to rival its own future air superiority programs. South Korea and Australia, however, are considering collaborative partnerships with Japan to co-develop next-generation fighter technologies. Japan's defense ministry has grand plans for the F-23J, and the first prototype is expected to take its first flight by 2027. The F-23J is slated to go into production in full by the early 2030s, with at least 100 units expected to be deployed. Japan is developing a carrier-based variant of the F-23J to equip future aircraft carriers in the future. In addition, the country is working on a hypersonic bomber that will be using much of the technology created by the F-23J. With the F-23J as its top aircraft, Japan is not just enhancing its own defense, but emerging as a world aerospace technology leader. Export negotiations for possible export orders already exist, and countries like Australia and the United Kingdom are already showing interest in buying the planes. What was junk is now Japan's finest war treasure. The F-23J, Phoenix risen from the ashes of the YF-23, will offer air superiority revolutionary in hypersonic speed, computer war, and unmatched stealth. The revival of the YF-23 as the F-23J is a jewel in the history of military aviation. The cutting-edge fighter, once branded as a failure, is staging a comeback in dramatic style, equipped with the best technology and a new mission to safeguard Japan's airspace. Unmatched stealth, hypersonic power, and AI combat systems put the F-23J poised to revolutionize the balance of power in the Indo-Pacific region in the world. The YF-23's main radar-absorbent materials were supplemented with plasma-based stealth technology, a new platform that reflects electromagnetic waves to substantially cut the airplane's radar footprint. The aircraft's electromagnetic wave absorbers and composite materials make the plane essentially radar invisible, as well as infrared invisible. If the fighter jet is a success, it will not be long before Japan is a player in the ranks of world super defense exporters, joining Australia and the UK most likely to modernize their own forces with advanced Japanese fighter jets. To that extent, the F-23J is less a weapon than a statement that Japan is setting itself up as one of the world's leading defense forces. Apart from the technical marvel of the airfighter, its revival has behemoth's psychological effects on global defense policy. War is guns, but also mind, and in reviving the YF-23 in a totally different incarnation, Japan has declared a paradigm shift in its defense policy. This move forces competitors like China and Russia to recalculate their own mathematics on the military, because the rebirth of an airplane that was considered too advanced when it flew decades ago leaves one wondering. Military planners must redo their strategic calculus now that they understand Japan is no longer merely playing defense, but is actively building its way toward regional air superiority. The introduction of the F-23J to the Indo-Pacific rebalances power and causes competitors to redeploy resources in order to combat this nascent threat. Slowness costs as much as defeat in this war, and Japan's move to resurrect the YF-23 is a strategic maneuver to make competitors hold back. The F-23J is far more than a replica of the YF-23. Japan has redesigned it from scratch, and it is among the world's top fighters. The heart of the F-23J is an entirely new stealth system that outperforms anything of the last generation. The YF-23's early radar-absorbent materials have now been replaced by plasma-based stealth technology, a newer system that deflects electromagnetic waves off to decrease the radar signature of the aircraft dramatically. The electromagnetic wave absorbers and the composite materials used in the aircraft also make it essentially invisible to radar and infrared detection systems. This shift is more than simple perception. It suggests a dramatic shift in Japanese military policy. Japan's self-defense forces for decades had been structured around an interception-centered air force, designed primarily to defend against threats approaching and not to project force. The coming of the F-23J, however, signals that Japan no longer contentedly protects only its airspace. Instead, it is turning towards a preemptive policy in which it can strike threats even before they enter Japan's borders. Apart from being a huge defense development, the F-23J is also a massive economic and industrial success for Japan. Producing a next-generation fighter aircraft has been about protecting one's nation. It's also about world economic and technological domination. With billions of dollars already invested in the project, Japan's defense industry is experiencing a historic boom, with thousands of high-tech positions created and innovation in aerospace engineering, avionics, and weaponry. Most importantly, this program is part of a broader effort to wean Japan away from American defense technology so that future military capabilities will remain under Japanese control. After being relegated to the pages of history, the YF-23 has been resurrected as the F-23J, one of the most advanced fighter planes in the world. With next-generation stealth technology, hypersonic capabilities, and AI warfare, Japan is making a statement. It will not be left behind in the race for arms. But Japan's rise to air dominance won't be easy. While China and Russia are barreling toward their own sixth-generation fighter projects, the skies of the Indo-Pacific are becoming increasingly contested on a scale unseen before. Will the F-23J forever solidify Japan's position as an air power giant, or has it just paved the way for the next great aerial armaments race? Russia's tanks have been crumbling like tin cans in Ukraine, Germany's mighty Leopard 2 crushes everything in its path. Its 120mm cannon tears through armor, while advanced systems detect enemies miles away. With unmatched speed, agility, and nearly impenetrable armor, it outclasses anything on the battlefield. Will this tank render Russia's weapons useless? Will this steel giant shift the balance of global power and redefine modern warfare? Join us as we uncover everything about Germany's $3 billion laser system tank. After the Cold War, tensions between East and West were rising. In 1963, Germany and America launched a joint tank project, the MBT-70, aiming to create a super tank that could outmatch anything from the Soviet Union. However, by 1967, the project was plagued with skyrocketing costs and technical failures. Germany could not wait, so military leaders turned to Porsche to explore upgrades for their Leopard 1 tank. Porsche engineers named their study the Vergold-Eder Leopard, or Gilded Leopard. They envisioned game-changing features like an automatic loader, a secondary cannon, and even a camera on an extendable pole to scout enemies from cover. Around the same time, Germany launched Experimental Entwicklung, meaning experimental development, setting aside 25 million German marks, later increased to 32 million. Krauss-Maffei led the project, working alongside Porsche on the hull and Wegmann on the turret. By 1969, 2 test vehicles, nicknamed Keiler, meaning wild boar, were built. These were not just improved Leopard 1 tanks, but platforms for testing new technology. The goal was to ensure accurate shots at 2,000 meters, over a mile, even while moving over rough terrain. Meanwhile, the MBT-70 project was collapsing. One major flaw was placing the driver inside the turret, making operations disorienting. Germany pulled out in 1969 and attempted a last-ditch modification, but the effort never advanced beyond a wooden model. In 1971, Germany decided to abandon failed projects and focus on the promising Keiler design. The tank was officially named Leopard 2, with Paul Werner Krapke leading its development. 2 versions were planned, the gun-armed Leopard 2K and the missile-launching Leopard 2FK. That year, Germany ordered 17 prototypes, though only 16 were built, for testing various configurations. 10 had 105mm guns, while 7 featured larger 120mm smoothbore guns. 2 hulls used experimental suspensions inspired by the MBT-70 with fewer road wheels. These prototypes introduced advanced features like precise rangefinders, stabilized guns for accurate firing on the move, and spaced armor for extra protection. By 1973, the tank's design kept evolving. Engineers developed a sharply angled turret, nicknamed the Shrew turret for its distinctive shape. Then the Yom Kippur War in the Middle East revealed a crucial lesson. Tanks needed much stronger armor to survive modern battlefields. In response, Leopard 2 was redesigned with heavier but more effective protection. Despite early struggles, constant innovation turned Leopard 2 into one of the most successful tanks in history. After years of testing, tweaking, and going back to the drawing board, the Leopard 2 was finally taking shape. But could German engineers turn their ambitious designs into a real tank that armies around the world would want to buy? The answer came in January 1977, when Germany made its first official order for the new tank. Instead of rushing into mass production, they wisely started with just 3 test tanks, 2 complete with turrets and 1 hull, to make sure everything worked perfectly. These pre-series vehicles arrived in 1978 with extra armor on the front, giving engineers one last chance to find and fix any problems. One of these test tanks went straight to the German Army School in Munster, where soldiers, not just engineers, could try it out in realistic conditions. Their feedback was crucial in making sure the final design would work well in the hands of regular tank crews. Satisfied with the results, Germany placed a massive order in September 1977 for 1,800 Leopard 2 tanks to be built in 5 big batches. This was no small project. It would take years to complete. The main company, Krauss-Maffei, could not handle such a huge order alone, so Maschinenbau Kiel was brought in to build nearly half the tanks. The first batch would include 380 tanks, with just 6 tanks scheduled for delivery in 1979, 114 for 1980, 180 for 1981, and then 300 tanks each year after that. On October 25, 1979, a historic moment arrived when the very first production Leopard 2 rolled off the assembly line. By 1982, workers at both factories had completed all 380 tanks from the first batch. Krauss-Maffei built 209 of them, with chassis numbers 10,001 to 10,210, while Maschinenbau Kiel delivered 171, with chassis numbers 20,001 to 20,172. Some of these early tanks did not have all the planned equipment. The special night vision thermal sights were not ready yet, so they got older image intensifiers instead. When the thermal sights finally became available, crews went back and installed them in the earlier tanks. Germany's appetite for these powerful new tanks kept growing. After the original 5 batches, they ordered 3 more, bringing Germany's total to an impressive 2,125 Leopard 2 tanks. The 6th batch of 150 tanks was ordered in June 1987 and built between January 1988 and May 1989. The 7th batch added 100 more tanks between May 1988 and April 1990. The final German order for 75 tanks was completed between January 1991 and March 1992. During the height of Cold War tensions, German factories were churning out 16 Leopard 2 tanks every month, about 1 every other day. Even though production slowed after the Cold War ended, the companies kept their equipment and skilled workers ready, just in case they needed to ramp up production again quickly. By the early 1990s, the Leopard 2 had transformed from an experimental project into one of the most successful tank designs in history. With thousands of Leopard 2 tanks now spread across the globe, many wondered what exactly made this German machine so special. What secret technologies and engineering tricks gave the Leopard 2 its fearsome reputation on the battlefield? At the heart of every great tank lies its armor, the protective shell that keeps the crew alive when enemy shells come flying. The Leopard 2's armor is not just thick steel like tanks of the past. Instead, it uses a special sandwich of different materials called spaced multi-layer armor. This clever design combines steel plates of different hardness levels with elastic materials and non-metal components. German engineers studied exactly how enemy anti-tank weapons work, especially the dangerous shaped charges that can burn through normal armor. They discovered that using layers of different materials could disrupt and weaken these deadly jets of super hot metal before they could reach the crew inside. The protection on the front of the Leopard 2 Alpha 4 is about 800 millimeters thick, which is nearly 3 feet of armor. Later versions like the 2 Alpha 5 got even better protection with wedge-shaped armor pieces that increased the thickness to 1,500 millimeters. These angled armor blocks make enemy shells glance off instead of hitting straight on. Experts estimate the 2 Alpha 4's frontal armor provides protection equal to 590 to 690 millimeters of solid steel against tank shells and 600 millimeters against shaped charges. The newer 2 Alpha 6 is even tougher, with protection equal to 920 to 940 millimeters of steel on the turret. But armor is not perfect. If a shell does break through, the Leopard 2 has another trick: compartments. The ammunition is stored in special areas separated from the crew. If shells in the turret explode, blow-off panels in the roof direct the blast upward, away from the crew. However, there is one weakness. The 27 shells stored in the hull do not have this protection, which could cause a catastrophic explosion if hit. Companies like IBD, Dyson-Roth, and ROEG have created add-on armor packages with names like Mexus, AMAP, and SidePro ATR to make the tank even harder to destroy. Some Leopard 2 tanks also have slat armor, metal cages that defeat rocket-propelled grenades before they can hit the main armor. The Leopard 2's main punch comes from its massive 120mm smoothbore gun made by Rheinmetall. Unlike older guns with rifling, this smooth-walled gun can fire special dart-like shells with incredible accuracy. The newer Lima 55 version of this gun is longer than the original Lima 44, giving shells more speed and power. These shells are amazing feats of engineering. The Delta Mike 53 round can punch through 750 millimeters of armor steel at 2,000 meters. That is like shooting through 2.5 feet of solid steel from over a mile away. The gun can even fire the Israeli Lima Alpha Hotel Alpha Tango missile to hit targets up to 6,000 meters away. The tank carries 42 shells, a total of 27 in the hull, and 15 in a special compartment in the back of the turret. It also has 2 machine guns, one next to the main gun and another on top for shooting at aircraft or infantry. What makes the Leopard 2 truly special is its ability to hit targets while moving over rough ground. This magic happens thanks to the Echo Mike Echo Sierra 15 fire control system. It combines a laser rangefinder that measures the exact distance to targets and a thermal camera that sees in the dark by detecting heat. A powerful computer takes information about the target's distance, the tank's speed, the weather, and even the Earth's rotation to calculate the perfect firing solution in seconds. The beating heart of this 60-ton beast is the Mike Tango uniform Mike Bravo 873 Kilo Alpha 501 engine, a massive 12-cylinder diesel that produces 1,500 horsepower. That is about the same power as 15 family cars combined. This powerful engine pushes the tank to speeds of 68 kilometers per hour on roads and gives it a range of 500 kilometers before needing to refuel. All these technologies work together to create a nearly perfect balance of protection, firepower, and mobility. But the real question remained: how would these sophisticated machines perform when the shooting started for real? With all its impressive technology and clever design features, the Leopard 2 looked unstoppable on paper. But as any soldier will tell you, real combat is different from tests and training. In 1984, German engineers began making important changes to their prized tank. The Leopard 2 Alpha 4 version added a digital ballistic computer that made firing even more accurate. They also improved the fire extinguishing system to better protect crews if something went wrong. By 1989, German military planners realized that tanks, like all technology, needed regular updates to stay ahead of the competition. They launched an ambitious program with a very German name, Kampfwertsteigerung, which simply means combat value improvement. This program had 3 main goals: better armor, a more powerful gun, and improved electronics. The first major upgrade came with the Leopard 2 Alpha 5 in 1995. The most visible change was the new arrow-shaped armor on the turret. These angular blocks weren't just for show, they were carefully designed to deflect incoming shells. Between 1995 and 1998, Germany upgraded 225 of their tanks to this new standard. They liked the results so much that they converted another 125 tanks between 1999 and 2002. The next big jump came with the Leopard 2 Alpha 6, which featured a longer gun barrel, the Lima 55 instead of the older Lima 44. This longer barrel gave shells more speed and hitting power, making the tank even deadlier at long ranges. Between 2001 and 2005, Germany converted 225 tanks to this new standard. The third planned stage would have been truly revolutionary, replacing the entire turret with a new design featuring a massive 140mm gun and an autoloader to replace the human loader. Engineers built and tested a prototype with this huge gun, but the project was canceled in 1995. With the Cold War over, the threat of massive tank battles in Europe had faded, and the cost seemed hard to justify. While these upgrades were happening, the peaceful 1990s gave way to a more dangerous world. For the first time, Leopard 2 tanks would face real combat conditions. The baptism of fire came in Kosovo, where German peacekeeping forces deployed their Leopard 2s to keep warring factions apart. Though they didn't face direct combat, these missions taught valuable lessons about operating heavy tanks in difficult terrain in unstable regions. The real test came in the mountains of Afghanistan after the 9/11 attacks. Dutch, Danish, and Canadian forces brought their Leopard 2s to this harsh environment as part of the International Security Assistance Force. Many experts had claimed that Afghanistan, with its rugged mountains and narrow valleys, was no place for heavy tanks. The Leopard 2 proved them wrong. Canadian tankers found that their Leopard 2s could go places other vehicles couldn't, providing crucial fire support for infantry and firefights with Taliban fighters. The tanks' excellent optics could spot hidden enemies, and their powerful guns could destroy fortified positions with a single shot. But Afghanistan also revealed limitations. The original tanks weren't well protected against the buried bombs, called improvised explosive devices, that became the Taliban's weapon of choice. This led to new variants like the Leopard 2 Alpha 4 Mike and 2 Alpha 6 Mike, with added armor on the bottom of the hull to better survive mine blasts. Engineers also developed special armor kits for urban fighting, where threats could come from any direction. The Leopard 2 Alpha 4 Mike Can and Leopard 2 PSO added armor modules along the sides of the turret and hull, plus metal cage armor at the back to defeat rocket-propelled grenades that could penetrate up to 600 millimeters of steel. These combat experiences transformed the Leopard 2 from a tank designed to fight Soviet armies on European plains into a versatile fighting vehicle that could handle peacekeeping, counterinsurgency, and urban combat. With each mission, crews and engineers learned new lessons that fed into further improvements. But as effective as these midlife upgrades were, the world of military technology never stands still. By 2014, newer threats were emerging that would demand even more advanced solutions. While the Leopard 2 proved itself through decades of upgrades and limited combat experience, a new question emerged on the horizon. How would this battle-tested tank adapt to the rapidly changing warfare of the 21st century? In 2014, a new chapter began for Germany's famous tank. The Leopard 2 A7 rolled out to soldiers, showing off its latest improvements. Only 20 tanks came in this first batch, but they marked the start of something new. The 2A7 was not just another upgrade. Engineers gave it better armor on the bottom to protect against hidden bombs and mines that fighters often use in modern conflicts. They also added special holders where extra armor plates could be attached when needed, especially for fighting in cities. The 2A7 can handle today's threats better than any version before it, said one German defense official when the tanks were delivered. Even before these new tanks reached soldiers, German planners were already thinking about what to change next. They wanted to keep the tank's famous mobility while making it even more protected. They also started working on better cameras and vision systems to help tank crews see the battlefield more clearly. But a challenge appeared in 2015. Reports claimed that the special tungsten bullets used by Leopard 2 tanks could not break through the armor of Russia's newest T-90 tanks or their upgraded T-80s. German weapons makers quickly began developing new, more powerful bullets specifically for the 2A7 version. At the same time, the company Rheinmetall started work on something even bigger, a new 130mm gun to replace the standard 120mm gun on Leopard tanks. This bigger gun would be 50% more powerful and could punch through tougher armor. By 2016, they were ready to start telling potential buyers about this new weapon. Looking further ahead, German military planners know the Leopard 2 will not last forever. The tanks first entered service in 1979, and they expect them to serve until around 2030. In May 2015, Germany and France agreed to work together on a completely new tank that would eventually replace both the German Leopard 2 and the French Leclerc. This new project, called the Main Ground Combat System, will not be ready right away. Until then, the Leopard 2 will keep getting updates. These include a new digital brain for the turret, better awareness systems to help crews understand what is happening around them, and active protection systems that can shoot down incoming rockets before they hit the tank. Protection against modern threats remains a top concern. In February 2021, Germany decided to buy the Trophy system from Israel, a special defense system that can detect and destroy anti-tank missiles in midair. The plan is to fit this system on 17 German Leopard 2A7A1 tanks by 2023, with lessons learned helping to improve the future Leopard 2A8 version. The Leopard 2 has changed a lot since its birth in the Cold War. Today's versions face very different threats, from hidden bombs in city streets to advanced missiles and drones. But with each upgrade, the tank has adapted. As warfare continues to change, so will this German tank. And when it finally retires around 2030, its successor will build on 5 decades of lessons learned in peace and war. While America was sleeping, the F-22 Raptor went through a transformation that military experts cannot ignore. With an $11 billion upgrade, It now boasts stealth coatings that change color, hypersonic missiles reaching Mach 5, and advanced pilot AI integration. This upgrade pushes it towards sixth-generation status. What deadly new capabilities make our enemies tremble at the mere mention of Raptor 2.0? And how will this invisible phantom reshape the future of aerial warfare forever? Join us as we find out what makes the $11 billion upgrade of the U.S. F-22 Raptor's sixth-generation program so shocking. During the 1990s, American military leaders recognized the need for an advanced fighter jet capable of evading enemy detection. This led to the development of the F-22 Raptor, a highly sophisticated aircraft that transformed aerial combat. Introduced in 1997 and making its first official flight for the United States Air Force in 2005, the F-22 was designed to dominate the skies. Engineers developed it with stealth technology, using specialized materials and a carefully designed shape to reduce radar visibility. The jet possessed exceptional speed and maneuverability, making it difficult to engage. Also, its advanced weaponry allowed for precise and effective strikes. The cockpit of the F-22 had state-of-the-art technology that integrated data from multiple sensors, a capability known as sensor fusion. This provided pilots with a comprehensive view of the battlefield without overwhelming them with excessive information. As a result, they could detect threats from long distances and respond swiftly. Developing such an advanced aircraft presented significant challenges. Each F-22 cost approximately $150 million to produce, making it one of the most expensive fighter jets ever built. Its complex systems required extensive maintenance, with mechanics undergoing specialized training to service the aircraft. For every hour of flight, the jet required about 30 hours of maintenance work. Initially, the Air Force planned to procure 750 Raptors. However, due to high costs and shifting military priorities, the order was significantly reduced. By 2011, only 187 units had been produced before the production line was discontinued. Some military analysts expressed concerns about whether this number would be sufficient for future defense needs. As newer fighter jets such as the F-35 Lightning II were introduced, discussions emerged regarding the role of the F-22. The F-35 offered additional capabilities, including vertical takeoff and landing, as well as enhanced compatibility with Allied Forces systems. Although it was more versatile and cost-effective per unit, it did not match the F-22's superior speed and maneuverability. This presented the Air Force with a significant challenge: whether to allow its premier air superiority fighter to become outdated or to find a way to maintain its technological edge. The decision came in 2016 with the introduction of the Advanced Raptor Enhancement and Sustainment Program, a comprehensive initiative aimed at modernizing the aircraft. The stakes were considerable. Both Russia and China were developing their own stealth fighter jets, narrowing the technological advantage that American pilots had relied on for decades. To ensure continued air dominance in the 21st century, the F-22 required upgrades. But with Russia and China racing to build their own advanced fighter jets, the United States Air Force couldn't afford to let their prize Raptor fall behind. What exactly was in the mysterious upgrade program that would cost American taxpayers a staggering $11 billion? In the Pentagon in 2016, a small team of military leaders made a strategic decision. Rather than allowing the F-22 Raptor to become obsolete, they initiated a program with a name reminiscent of a covert operation, the Advanced Raptor Enhancement and Sustainment Program, or ARES. Named after the Greek god of war, the ARES program's objective was to develop not just improved aircraft, but an entire family of systems designed to maintain air superiority for decades. To safeguard this initiative, the Air Force kept many details classified. Although the F-22 was already highly advanced, military analysts recognized that adversaries were making significant progress. China's J-20 and Russia's Su-57 stealth fighters were improving each year, challenging the United States' technological advantage. The most significant component of ARES was known as Raptor 2.0, or by its official designation, Increment 3.2 Bravo. This was more of a comprehensive transformation intended to elevate the F-22 into what would be considered the world's first sixth-generation fighter jet. Implementing these upgrades required years of meticulous engineering. Designers had to enhance critical components of the jet, while maintaining its fundamental structure. They refined the radar-absorbing coating, integrated advanced sensors capable of detecting enemy aircraft from greater distances, and upgraded the onboard computing systems to improve pilot decision-making in combat. By September 2020, the Air Force made an unexpected announcement. It had secretly designed and flown a prototype of a next-generation fighter jet, developed as part of the broader ARES initiative. This revelation surprised many experts who had not anticipated the existence of such a project. Meanwhile, efforts continued to modernize the existing fleet of F-22 aircraft. Teams of skilled technicians worked in highly secure hangars across the country, carefully dismantling and reconstructing these jets with the latest technological advancements. When the upgrade was completed in 2022, the F-22 had undergone a remarkable transformation. Once regarded as the world's most advanced fifth-generation fighter, it had evolved into an intermediary between fifth and sixth-generation capabilities, incorporating innovations that military strategists had envisioned a decade earlier. But while the ARES program sounded impressive on paper, what exactly changed about the Raptor that justified spending $11 billion, enough money to build a small city? What groundbreaking technologies turned this already fearsome fighter into something that military experts call a weapon of the future? The core of the F-22's extensive upgrade is in a feature that is not immediately visible: its exterior coating. While the new surface treatment on the upgraded Raptors appears ordinary to the naked eye, it is actually one of the most advanced materials ever developed for military use. This coating is composed of specially engineered nanomaterials, microscopic structures that are thousands of times thinner than a human hair. These materials reduce the aircraft's radar signature by half. In practical terms, if the original F-22 appeared on radar with the visibility of a bird, the upgraded version is more comparable to a bee. Enemy radar operators might detect a brief, fleeting signal, if at all, before it disappears. However, the coating does more than minimize radar detection. It also has the capability to self-repair minor scratches and surface damage, which would otherwise increase the aircraft's visibility to detection systems. This self-healing function operates similarly to human skin, where the material gradually reforms and closes small imperfections. One of the most notable features of this new coating is its ability to adapt its color based on the surrounding environment. When flying at high altitudes, the aircraft shifts to blend with the blue sky. At lower altitudes over desert or forested terrain, it adjusts accordingly, making visual detection significantly more challenging. Test pilots who have flown the upgraded F-22 report that these enhanced stealth capabilities provide them with increased confidence when operating in areas protected by advanced anti-aircraft defenses. One pilot described the experience as similar to wearing an invisibility cloak. Beyond its enhanced stealth, the aircraft's sensor systems have undergone significant advancements as well. The newly integrated sensor suite provides pilots with an unprecedented panoramic view of the battlefield. The Active Electronically Scanned Array Radar, or AESA, offers improved resolution and extended detection range while remaining difficult for enemy forces to track. The Infrared Search and Track System, or IRST, detects the heat signatures of aircraft engines from considerable distances, even when those aircraft employ stealth measures. This allows F-22 pilots to locate and engage targets without activating their own radar, a critical advantage in maintaining a tactical edge. Complementing these systems, the Electro-Optical Targeting System delivers high-resolution visual identification of targets in both daylight and nighttime conditions. Additionally, the Distributed Aperture System utilizes multiple cameras positioned around the aircraft to provide a comprehensive real-time feed into the pilot's helmet display. This innovative feature enables pilots to see through the aircraft's fuselage, offering a complete field of view by simply turning their head. All of this information is seamlessly integrated into a specially designed helmet that projects essential data directly onto the pilot's visor. Instead of having to glance down at cockpit screens, pilots can maintain focus on their surroundings while simultaneously monitoring crucial information such as altitude, speed, weapon status, and target locations overlaid onto their field of vision. Air Force officials emphasize that these advanced sensor systems are not only more effective, but are also designed to function together, automatically sharing information to provide pilots with a clear and comprehensive operational picture without overwhelming them with excessive data. With the ability to see everything and remain virtually invisible, the upgraded F-22 has changed the rules of aerial combat. But what good is being the stealthiest fighter in the sky if you can't strike with deadly precision? What lethal surprises does the Raptor now carry in its hidden weapons bays? Inside the upgraded F-22 Raptor is a carefully concealed arsenal that matches or surpasses any other aircraft in the sky. Unlike older fighter jets that carry weapons on external racks, making them more detectable on radar, the F-22 stores its weapons in internal compartments, preserving its stealth profile until the moment of engagement. The upgraded Raptor can now carry up to 8 air-to-air missiles within these internal bays. 4 of these are AIM-120 DMRMs, or Advanced Medium-Range Air-to-Air Missiles, capable of striking targets at distances exceeding 100 miles, far beyond what pilots can see unaided. The remaining 4 slots typically house AIM-9X Sidewinders, highly maneuverable, heat-seeking missiles designed for close-range combat. One of the most significant additions to the F-22's weaponry is its ability to carry 2 AIM-260 JOATMs, or Joint Advanced Tactical Missiles. These next-generation weapons were specifically developed to counter similar long-range missiles introduced by Russia and China. While the exact range of the AIM-260 remains classified, military analysts estimate that it surpasses the range of the MRM while also being more difficult to evade. For striking ground targets, the upgraded F-22 is now equipped to carry the AGM-183A ARW, or Air-Launched Rapid Response Weapon, commonly referred to as ARROW. This is a hypersonic weapon, meaning it travels at speeds exceeding 5 times the speed of sound, or more than 1 mile per second. At these extreme velocities, current defense systems find it nearly impossible to intercept. Additionally, the kinetic energy alone from an object traveling at speeds above Mach 5 generates immense destructive force upon impact. Having advanced weapons is only beneficial if pilots can accurately locate their targets, which is why the F-22's communication systems have undergone a significant overhaul. The core of this upgrade is a secure data link known as the Multi-Function Advanced Data Link, or MADL. This system enables Raptors to exchange information seamlessly with one another and with F-35 fighters without exposing their positions to enemy sensors. The upgraded Raptor is also equipped with the Battlefield Airborne Communications Node, or BACN, which serves as a bridge between different military systems. Through BACN, the F-22 can communicate with satellites, ground forces, naval vessels, and even older aircraft that use different communication protocols. Air Force strategists believe that this combination of enhanced stealth, advanced sensors, powerful weaponry, and networked communication capabilities makes the upgraded F-22 the most dominant air combat platform ever developed. Even as potential adversaries introduce their own stealth aircraft and sophisticated air defense systems, the Raptor's $11 billion upgrade ensures that it remains at the forefront of aerial superiority. While the F-22 upgraded weapons and communications make it deadly in combat, how does this technological marvel perform when pushed to its absolute limits? On a clear day over Fort Lauderdale, Florida, a single F-22 Raptor approaches the shoreline as thousands of spectators watch in anticipation. The crowd falls silent, awaiting what is more than just an air show. It is a demonstration of one of the most agile aircraft ever built. Captain Samuel Larson, known as Raz, sits in the cockpit, preparing for the first ever flare display in the F-22 Raptor demonstration. His hands rest on the controls of the fighter jet, which has a production cost of approximately $350 million. The audience is unaware that they are about to witness a historic moment in aviation. Flares serve as defensive tools designed to counter heat-seeking missiles. These small devices burn at extremely high temperatures, typically between 1,200 and 2,000 degrees Fahrenheit, creating an infrared signature that diverts incoming threats from the jet's engines. The F-22 carries up to 60 flares, stored within internal dispensers. On this occasion, these countermeasures will be integrated into a performance that displays the Raptor's remarkable capabilities. Captain Larson begins with a vertical climb at maximum thrust. The aircraft's twin Pratt & Whitney F-119 engines, each generating 35,000 pounds of thrust, propel the jet skyward at nearly twice the speed of sound. As the Raptor ascends, Larson deploys the first set of flares, leaving behind a striking trail of orange-white fire. The crowd watches in awe. Next, he executes the Cobra maneuver, an aerial feat that challenges conventional flight dynamics. The aircraft pitches its nose upward at a 90-degree angle while maintaining forward motion. Unlike most planes which would stall under these conditions, the Raptor remains controlled. As the nose levels back down, another burst of flares creates a fan-like pattern against the sky. The Raptor achieves these extreme maneuvers through thrust vectoring nozzles that redirect engine thrust and an advanced flight control system that ensures stability. Following this, Larson performs the pedal turn. By using a combination of rudder control and thrust vectoring, he rotates the 43,000-pound aircraft around its vertical axis, causing it to spin mid-air like a top. A spiral of fire from the released flares adds a dramatic visual effect. The power loop comes next. Larson guides the F-22 through a perfect vertical circle while maintaining speed, a feat that requires both immense power and aerodynamic efficiency. Another set of flares is released, outlining the jet's circular path. For the grand finale, he executes the tail slide, temporarily flying the aircraft backward before regaining control. The Raptor can sustain flight at exceptionally low speeds, as slow as 60 knots without stalling, thanks to its computerized fly-by-wire system, which continuously adjusts control surfaces to maintain stability. As the performance concludes, the audience erupts in applause. Smartphones capture the moment, and soon, videos of the demonstration will spread across social media. The stunning aerial display of the F-22 showcases what was once considered the pinnacle of fighter jet technology, but with the $11 billion upgrade transforming it into something new. What exactly separates yesterday's top fighters from tomorrow's aerial warriors? And why does the distinction matter enough to justify such a massive investment? Fighter jets, like smartphones, evolve through generations, with each new iteration introducing significant advancements that transform aerial combat. Until recently, the F-22 Raptor was widely recognized as the leading fifth-generation fighter. Now, following a substantial upgrade, it integrates elements of sixth-generation technology, positioning it at the forefront of future aerial warfare. The distinction between fifth and sixth generation fighters extends beyond age or speed. Fifth generation aircraft, such as the original F-22 and the F-35 Lightning II, already possess advanced stealth capabilities. Their specialized designs and radar-absorbing materials make them challenging to detect on enemy radar. However, they are not entirely invisible, as sophisticated radar systems can still locate them under specific conditions. The difference in detectability is like comparing hiding behind a tree versus becoming the tree, explained retired Air Force Colonel James Michaels, who contributed to early stealth technology programs. Fifth-generation fighters already achieve remarkable speeds. The F-22, for example, can exceed 1,500 miles per hour, or Mach 2.25, and maintain supersonic speeds without engaging afterburners. This capability, known as supercruise, conserves fuel and extends the aircraft's operational range. Sixth-generation fighters aim to surpass Mach 5, entering the realm of hypersonic flight. At such speeds, a fighter jet could traverse the continental United States in less than 1 hour. Achieving this requires the development of materials capable of withstanding the extreme heat generated at these velocities. Advancements in sensor technology further distinguish these generations. Fifth-generation fighters already employ sophisticated radar and sensor fusion to integrate data from multiple sources. The F-35, for instance, can detect and track multiple targets from various angles simultaneously. Sixth-generation fighters incorporate artificial intelligence to analyze sensor data in real time. The upgraded F-22 can automatically identify threats, recommend tactical responses, and even predict enemy movements based on behavioral patterns. Some systems can recognize distinct signatures of enemy aircraft by analyzing subtle variations in engine noise or electromagnetic emissions. Weapons technology has also advanced considerably. Fifth-generation fighters primarily carry precision-guided missiles and bombs within internal weapon bays to preserve stealth capabilities. Sixth-generation aircraft introduce directed energy weapons, such as military-grade lasers, capable of disabling sensors or neutralizing targets instantly without depleting ammunition. Networking capabilities mark perhaps the most significant leap forward. Fifth-generation fighters can share basic targeting information with allied aircraft. Sixth-generation systems create an interconnected battle network where fighters, drones, satellites, and ground forces exchange data seamlessly. The upgraded F-22's multifunction advanced data link system represents a step toward this fully integrated combat environment. As Russia and China develop their own advanced fighters, Russia's Su-57 and China's J-20 currently represent their respective fifth-generation entries. The pursuit of sixth-generation technology has become crucial to maintaining air superiority. The upgraded F-22 stands at the intersection of these advancements. While not a fully realized sixth-generation fighter, it incorporates key technological innovations that extend its operational effectiveness and offer a glimpse into the future of aerial warfare. Russian helicopters have long been a force to reckon with, dominating battlefields and harsh environments alike. From the rugged Mi-24 Hind to the heavily armored Ki-52 Alligator, these machines are built for extreme conditions and brutal combat. But do they really stand out against their American counterparts? If yes, is it their superior design, firepower, or sheer battlefield adaptability that sets them apart? Join us as we explore why Russian helicopters are believed to be ahead of American. Helicopters have been a very important part of both Russia and the U.S. military missions for decades, offering unmatched versatility in combat, transport, and rescue. The story of the U.S. helicopters began in the 1930s with early designs that paved the way for today's powerful aircraft. Over the years, U.S. military helicopters have become more advanced, built to withstand extreme conditions like deserts, jungles, and war zones. Now, U.S. helicopters are packed with advanced technology, making them faster, deadlier, and more precise. The Black Hawk is known for transport and rescue missions, while the Apache is a fearsome attack helicopter loaded with advanced weapons. However, some experts claim that Russia's helicopters, especially those built by Russian helicopters, are far ahead in performance and technology. Russian models like the K-52 and Mi-28 are praised for their armor, firepower, and ability to operate in harsh environments. But does this mean Russia has truly taken the lead? And how close to the truth is this claim? Let's get into it. Helicopters first appeared as military tools in the 1930s, with both Germany and the United States exploring their potential. These early flying machines were quite different from the advanced helicopters we see today, but they laid the foundation for modern military aviation. Germany took an early lead with the Heinkel 49, one of the first military helicopters. It was mainly used for reconnaissance, helping spot enemy movements from above. This marked the start of helicopters playing a role in warfare. More German designs soon followed, including the Flettner FL-282 Colibri and the Focke-Wulf FW-61. These helicopters were small and fast, with the ability to hover and move in tight spaces, making them useful for specific missions during World War II. However, their service was limited due to wartime production challenges. On the other side of the Atlantic, the United States was also working on helicopter technology. The Vought Sikorsky VS-300 was a key breakthrough. This helicopter had multiple engines and introduced design features that influenced future models. It led to the creation of the Sikorsky XR-4, which became the first helicopter to be mass-produced for the U.S. military. The XR-4 proved that helicopters could be reliable tools for combat and support operations, pushing the U.S. to invest more in rotorcraft technology. Meanwhile, Britain also recognized the value of helicopters. The British military used hoverfly helicopters for rescue missions during the Second World War, helping recover downed pilots and injured soldiers. These early rescue operations demonstrated how helicopters could reach places that traditional aircraft could not. After the Second World War ended, helicopter technology rapidly improved. One of the most important developments was the YH-13 Sioux, which played a crucial role during the Korean War. This helicopter became famous for medical evacuations, quickly transporting wounded soldiers from the battlefield to hospitals. The ability to airlift injured troops in a matter of minutes saved countless lives and changed the way wars were fought. These early helicopters were just the beginning. Over the years, military helicopters became more advanced, with better speed, firepower, and durability. What started as small experimental aircraft soon became an essential part of modern warfare. After World War II, helicopters quickly became more advanced, especially during the Korean War. This war showed just how useful helicopters could be, especially for moving troops and rescuing wounded soldiers. Instead of relying only on traditional transport methods, the military now had fast, flexible aircraft that could land almost anywhere. Helicopters saved countless lives by carrying injured soldiers from the battlefield to hospitals in record time. During this period, several important helicopters were developed, each serving a unique purpose. The Bell H-12 Sioux was a light helicopter mainly used for reconnaissance, helping soldiers scout enemy positions. The Sikorsky H-5 played a crucial role in rescue missions, proving its worth by pulling injured troops out of dangerous situations. The Hiller OH-23 Raven was another scouting helicopter, small and quick, perfect for gathering intelligence. Meanwhile, the Sikorsky H-19 Chickasaw was much larger and capable of carrying heavy loads, making it ideal for transporting soldiers and equipment. After the war, helicopters became even more specialized. Engineers started designing helicopters for very specific tasks. One example was the Westland Wasp, a helicopter built specifically for hunting submarines. This was a game-changer for naval forces, allowing them to detect and attack enemy submarines more effectively. It wasn't just the military that saw the value of helicopters. Civilian helicopters also played a big role in shaping future designs. The Sikorsky S-51 and Bell 47 were among the most famous, used for things like medical transport, news reporting, and even agriculture. These helicopters introduced turbine-powered engines, which made them faster, stronger, and more reliable. The success of these civilian models influenced military engineers, leading to even better designs for combat helicopters. The Vietnam War is often seen as the most iconic period for military helicopters, thanks to the Bell UH-1 Huey. This helicopter changed warfare forever, becoming a symbol of the conflict. It was used to transport troops, carry supplies, and rescue wounded soldiers from the dense jungles of Vietnam. Before helicopters like the Huey, moving soldiers and evacuating the injured took much longer and was far more dangerous. But with the Huey's ability to land in tight spaces and take off quickly, military tactics changed completely. The U.S. Army could now deploy troops rapidly and provide medical help faster than ever before. The Vietnam War also introduced another game-changing helicopter, the Bell AH-1 Cobra. This was the first helicopter built specifically for attacking enemy forces. While the Huey focused on transport, the Cobra was designed for combat, armed with powerful guns and rockets. These helicopters showed the world how helicopters could dominate the battlefield, and their success shaped the future of military aviation. After the Vietnam War, military helicopters continued to improve, especially during the Cold War. As tensions between the U.S. and the Soviet Union grew, the need for better helicopters became more urgent. The military needed helicopters that could move faster, carry heavier loads, and handle more dangerous missions. One of the most important helicopters to emerge during this time was the AH-64 Apache. Introduced in 1984, the Apache was a powerful attack helicopter, packed with advanced weapons, night vision technology, and strong armor. Unlike earlier helicopters, the Apache could target enemies with precision and survive in intense battle conditions. Even today, it remains one of the deadliest military helicopters in the world. Another major advancement was the UH-60 Black Hawk, introduced in 1979. This helicopter became a key asset for the U.S. military, used for transporting troops, evacuating the wounded, and delivering supplies. The Black Hawk was faster, more durable, and more versatile than previous transport helicopters, making it a crucial part of modern military missions. For carrying heavy loads, the CH-47 Chinook, introduced in 1962, became the go-to helicopter. With its twin rotors, the Chinook could lift massive amounts of cargo, making it essential for moving supplies, vehicles, and even other helicopters. It was particularly useful in tough terrains where trucks or planes couldn't reach. These helicopters weren't just improvements. They completely changed how wars were fought. With better technology, stronger firepower, and improved mobility, helicopters became a key part of military operations. Whether in combat, rescue missions, or transporting equipment, they proved to be irreplaceable. Today, these Cold War-era helicopters are still in use, constantly upgraded with the latest technology. Their impact on warfare is undeniable, and as military technology continues to advance, helicopters will remain a critical force on the battlefield. The U.S. military depends heavily on helicopters, with about 5,500 currently in service. These aircraft are essential for a wide range of missions, from transporting troops to launching attacks on enemy targets. With 317,000 personnel in the Air Force alone, helicopters is important in moving soldiers, supplies, and equipment quickly and efficiently. Their ability to take off and land without runways makes them ideal for operations in remote or dangerous areas. One of the most important helicopters in the U.S. military is the UH-60 Black Hawk. This helicopter is mainly used for transporting troops and carrying out medical evacuations. Its reputation for being tough and dependable makes it a key part of combat missions. The Black Hawk can operate in a variety of environments, including deserts, jungles, and urban battlefields, providing critical support to soldiers on the ground. In addition to troop transport, it is also used for search and rescue missions, disaster relief, and special operations. For heavy lift operations, the CH-47 Chinook is the military's top choice. This helicopter is designed to carry large amounts of cargo over long distances, making it essential for supplying troops and moving equipment. Its twin-rotor design gives it incredible lifting power, allowing it to transport everything from ammunition and supplies to vehicles and small boats. The Chinook's ability to carry heavy loads makes it invaluable in both combat and humanitarian missions. It has been used in disaster relief efforts around the world, delivering food, water, and medical aid to those in need. The U.S. military also relies on attack helicopters to provide firepower during combat missions. The AH-64 Apache is the most powerful attack helicopter in service, armed with radar-guided missiles, a 30mm chain gun, and advanced targeting systems. This helicopter is built for combat, capable of striking enemy positions with pinpoint accuracy, even in bad weather or at night. Its advanced sensors allow pilots to detect and engage threats from long distances, giving the military a significant advantage on the battlefield. The Apache has proven itself in numerous conflicts, including Iraq and Afghanistan, where it has been used to destroy enemy tanks, bunkers, and vehicles. The O-58 Kiowa was once a key reconnaissance helicopter, but it has been phased out of most roles. However, it is still used in limited operations, where its ability to gather intelligence remains useful. Reconnaissance helicopters play a crucial role in modern warfare, providing real-time information about enemy movements and battlefield conditions. The Kiowa's lightweight design allows it to move quickly and quietly, making it ideal for scouting missions. Meanwhile, the U.S. military has been modernizing its fleet with newer helicopters like the U-872A Lakota. This light utility helicopter is replacing older models like the UH-1 Huey, bringing improved performance and updated technology. The Lakota is used for a variety of missions, including search and rescue, border patrol, and training operations. Its versatility and efficiency make it a valuable addition to the military's helicopter fleet. Over the past 2 decades, significant advancements have been made in helicopter technology. The UH-60M Black Hawk has received upgrades that include newer engines and digital avionics, making it more powerful, reliable, and easier to operate. These improvements have increased its speed and maneuverability, allowing it to perform better in high-stress combat situations. Similarly, the CH-47F Chinook has been modernized with better engines and avionics, improving its ability to carry heavy loads over greater distances. These upgrades ensure that the Chinook remains one of the most effective transport helicopters in the world. One of the most innovative additions to the U.S. military's helicopter fleet is the V-22 Osprey. This unique aircraft is a tilt-rotor, meaning it combines the vertical takeoff and landing capabilities of a helicopter with the speed and range of an airplane. This hybrid design allows the Osprey to travel much faster and farther than traditional helicopters, making it an excellent choice for long-range missions. The Osprey has been used for a variety of operations, including special forces missions, troop transport, and humanitarian aid. Its ability to quickly deploy troops and supplies in difficult-to-reach areas has made it a valuable asset in modern warfare. Another major advancement is the AH-64D Longbow Apache, an upgraded version of the Apache attack helicopter. This model features an advanced radar system that enhances its ability to detect and engage enemy targets. The Longbow radar allows the Apache to track multiple threats at once, even when hidden behind obstacles like trees or buildings. This gives the U.S. military a significant edge in combat, allowing pilots to take out enemies before they even know they are being targeted. Helicopters like the UH-60 Black Hawk and AH-64 Apache have been essential in modern warfare, especially in conflicts like Iraq and Afghanistan. These powerful machines help transport troops, evacuate the wounded, and provide crucial air support during missions. Whether in combat or humanitarian operations, helicopters remain a key tool for the military. Helicopters play a major role in troop deployment, medical evacuation, reconnaissance, and close air support. They allow soldiers to be transported quickly, rescue the injured, gather intelligence, and attack enemy positions. However, warfare is constantly changing. Enemies are developing new tactics, and battlefields are becoming more complex. To stay ahead, the U.S. military must upgrade its helicopters to be faster, more efficient, and better suited for modern conflicts. As technology advances, the military is developing new helicopters under the Future Vertical Lift program, which will replace older models like the Black Hawk and Apache. These new aircraft will be faster, fly longer distances, and handle more demanding missions. One major project, the Joint Multi-Role Rotorcraft, is designed to create a new type of helicopter that can perform both attack and transport roles. It will be faster than current helicopters, with better maneuverability and more advanced weapons. The JMR rotorcraft will improve battlefield operations by responding to threats more quickly and covering greater distances. Another major development is the Joint Heavy Lift Rotorcraft, which will replace the CH-47 Chinook, the military's primary heavy lift helicopter. The JHL will be able to carry up to 29 tons of cargo over longer distances and at higher speeds. This will make it easier to move supplies, vehicles, and troops quickly, strengthening military logistics. The future of military helicopters will be shaped by groundbreaking technologies. Electric propulsion systems will reduce fuel use and increase efficiency. Autonomous flight capabilities will allow helicopters to operate with minimal human control. Advanced stealth technologies will make helicopters harder to detect by enemy radar. New designs like the Bell V-280 Valor and Sikorsky Defiant are leading this revolution. These helicopters will combine speed and agility, changing the way the military operates in future conflicts. With these advancements, the next generation of military helicopters will bring faster response times, more flexible mission capabilities, and lower operating costs. As war strategies continue to evolve, helicopters will remain a critical force in modern battlefields. The question now is, will these innovations be enough to maintain U.S. air dominance, or will rival nations take the lead? The technological rivalry between Russia and the U.S. has lasted for decades, with both nations leading in innovation and military advancements. This competition has produced groundbreaking technologies that continue to shape modern warfare. One area where this rivalry is particularly intense is helicopter development. But is Russia truly ahead of the U.S. in this field? Let's explore the evolution of Russian helicopters and see how they compare. In recent years, Russia has been rapidly increasing its production of military helicopters, and the numbers speak for themselves. On August 7, 2024, Sergei Kamazov, the CEO of Rostec, Russia's state-owned defense conglomerate, announced that helicopter production had more than doubled under the state defense order. In 2022, Russia produced 296 helicopters, a massive jump from the 134 made in 2021. This sharp increase is part of Russia's effort to strengthen its military capabilities amid the ongoing war in Ukraine and rising tensions with NATO. Russian attack helicopters, particularly the Mi-28 and K-52, have become a major force on the battlefield. Since June 2022, these helicopters have been playing a crucial role in targeting Ukrainian armored vehicles. They have destroyed newly supplied Western hardware, such as M2 Bradley fighting vehicles and Leopard main battle tanks, while also supporting Russian assaults on Ukrainian positions. Videos released by Russian military sources often show these helicopters in action, demonstrating their effectiveness in real combat situations. Despite the decline of some Russian military equipment since the Cold War, Russian attack helicopters are still considered among the best in the world. The Mi-28 and K-52 were developed from scratch after the Cold War and have been produced in large numbers since the 2010s. Another key attack helicopter, the Mi-35, is a modernized version of the Soviet-era Mi-24 and remains in service alongside the newer models. These helicopters are designed to be heavily armed, well-armored, and highly maneuverable, making them a formidable threat on the battlefield. To increase their effectiveness, Russia has also introduced a powerful new weapon, the Vikhor-1 missile, specifically designed for the Ka-52. This missile allows helicopters to attack enemy targets from a safe distance, reducing the risk of being shot down by Ukrainian air defense systems. With Ukraine's air defenses weakening over time, Russian attack helicopters have become even more dominant in the war. On August 7, new footage was released showing a K-52 attack helicopter launching a guided missile to destroy a Ukrainian armored vehicle hidden among trees in the Zaporozhye region. These kinds of attacks have been happening more frequently as Ukraine struggles to defend against Russia's aerial firepower. The growing success of Russian attack helicopters has been largely attributed to Ukraine's dwindling stock of air defense missiles, making it easier for helicopters to operate freely over the battlefield. As Russia continues to ramp up its production of military helicopters, questions remain about how long Ukraine can withstand these relentless aerial attacks. With more advanced helicopters and weapons entering service, the battlefield is shifting in Russia's favor. How will Ukraine and its Western allies respond to this growing air power advantage? Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.